Hello, everyone. Welcome back to Ask a Scientist Gaming, where we combine mediocre gameplay with expert science. I'm Ken Hansen, Associate Professor in the Department of Chemistry and Biochemistry at Florida State University. I'm a photochemist/photophysicist. I shine light on molecules and materials and track where that light energy goes, and hopefully do something useful with it, like generate electricity, like generate mechanical force, or make and break useful bonds. But more importantly, joining me today is Dr. Bin Ouyang. Bin, if you wouldn't mind introducing yourself.
Yeah, thanks a lot for the invitation. Very happy to be here. So my name is Bin Ouyang. I'm a second-year assistant professor in FSU chemistry. So I do computational stuff, and we use high throughput screening, machine learning, and data science tools to understand how to design mostly inorganic materials. But recently we are also looking at hybrid material. Organic chemistry is too hard for me. Yes. So my dream is actually to do the inorganic version of the fashion of organics, which is retrosynthesis. Yeah, so we build databases, we do machine learning, trying to understand how to turn like stones and sands into battery materials, for instance, or electrocatalysis and things like that. Yeah, very happy to be here.
All right. Well, what do you typically teach? What's your go-to class?
General chemistry for sure. I like general chem too. Like Ken is a pro on that. I benefit a lot from it. And also, hopefully, I'm gonna teach PChem a lot of in the future, like next semester, for instance. And also, graduate courses like kinetics, statistics mechanics. So those are basically my regular teaching courses.
All right. Yeah. Equally important, what game are we starting with?
Double Dragon 2.
Double Dragon 2. And you said it's been like 20 years since you played this last?
Oh, yeah. I played this with my little uncle in my neighborhood.
That's awesome.
Yeah.
Is your uncle going to be watching tonight?
I'm sure.
All right, go ahead. Press start.
Gotcha.
Let's get some. We'll let you settle in a little bit.
Yeah.
Chief Scientist, welcome back. Thank you for joining us. Yeah, we'll open up to questions in a little bit. Bin's playing a little Double Dragon for the first time in 20 years, but don't worry, he has infinite lives. He has zero risk of dying.
My favorite part.
This one, I think it's one like Contra, where as long as you play long enough, you will beat it.
Yeah.
Because you have enough lives to do so.
Yeah, my favorite type of game.
Yeah, no, we do mediocre gameplay. It's our motto, and it works pretty well.
Yeah.
But yeah, Double Dragon 2, this is one of the classics. Like when you talk about top 50 Nintendo games, this one usually makes the list.
Exactly.
Yeah. This and like Contra and Mario 3, and they're all classics, but... Yeah, so you said you play the Switch a little bit, or you did during COVID.
Oh, yeah.
But it's been a while. I think you can get this for the Switch, actually, if you want to...
maybe it's too old. I think maybe old generation.
So they have a Nintendo like pseudo emulator for the Switch. So it has something like 50 games or something like that. So you can get Super Nintendo.
I see. I should definitely try.
Yeah. No worries. Practiced.
Yeah. I'm still trying to get familiar.
Feel like it's coming back? Let me check the volume.
Gotcha.
Yeah, it's pretty good.
That works.
Boss fight. We'll let you do the boss fight, and then we'll start opening for questions.
Sure. Yeah, definitely.
Maybe you go on the door. I don't remember.
Yeah, I guess so. Maybe I should go back.
Oh, might be climbing that. Can you climb that? Like press up or something?
Yeah.
No?
Really? Maybe I can go. Oh,
there it is. There's a ladder.
There you go.
There we go.
Awesome. Oh.
And they have weapons. There you go.
I remember this sound,
for all your Mason needs. Yeah, the music and the sounds are what I remember most about these games.
Exactly.
All right. So no boss fight there. We'll assume you're settled into gaming a little bit. So the question we like to open up with on every stream is, every single person has a unique path. Like very few of us sought out to do this job, to be at FSU doing chemistry, for example. So the question is, what path led you to where you are? What were the major milestones? And in particular, there were moments where you're like, oh, I want to do science. I want to do, chemistry. I want to do theory.
Gotcha.
And what were those moments, and what was the path that took you here?
Yeah, it's for me, it's kind of a back and forth actually. Like, you know, like first of all, I'm better at chemistry than physics when I was a high school student, and I think chemistry is so cool. Like, I like experimental chemistry in the very beginning. Yeah, I want to be an experimental chemist. But what happened is, like, in my undergrad, I choose.
No worries, Infinite Lives.
Yeah, I actually choose material chemistry to start with. That's why I'm very applied right now. Like in USF, there's this kind of applied physics chemistry. Yeah, I think I'm kind of one of them. Yeah, and then I kind of did more like material science to begin with, and then in the second year of my undergrad, I realized I like programming. Yeah, so I seriously considered whether I should change my major to computer science.
Well, how did you realize you liked programming? It was a class?
Yeah, there's a class, and you know, we study C and then C++. Yeah, I really like it. I joined actually the university forum. So we design website for like a student voting, things like that.
Oh, nice.
Yeah, so all my colleagues they are actually all from like, you know, computer science, and yeah, sometimes you choose your major depends on what your friends does, right?
That's fair.
Yeah, so I almost changed my major at that time, and then I realized, you know, computer science sometimes it's kind of boring if you don't have a subject. Yeah, so I think maybe I should do computer science for, you know, materials or chemistry, this kind of thing. Yeah, that's cool. And at that time, when I was an undergrad, I think something like DFT is just rising up. It's like 2008 and things like that. Yeah. So I realized this is a cool thing, like we can really predict materials. Yeah, so this is like when I start to do computational materials and computational chemistry stuff. Yeah, so I start with nanomaterials at that time. And I predicted like nanoparticle growth and this kind of thing. Yeah, and then I did a PhD in 2D materials. And then I did my postdoc in batteries mostly because, you know, battery are rising up these years. Yeah, so...
It's popular.
Yeah, exactly. And then I think it's kind of interesting, like I'm more material science in my past 5 to 10 years. And now I'm eventually coming back to my initial choice, become a professor in chemistry. That's life, I guess.
Came full circle.
Yeah.
That's awesome.
That's awesome. And now I'm trying to go back to organic chemistry. That's interesting. I actually prefer organic chemistry in the very beginning. Yeah, so I think like this kind of named reactions are really cool. Like yeah.
Except when you have to memorize them.
Oh yeah, exactly.
Go in the door. Maybe jump right.
I'm not so sure.
Oh, maybe down the pipe.
Oh, you mean here?
Yeah.
Oh, gotcha.
Yeah. There we go.
Yeah.
Contra, welcome back. Thank you for joining us, playing a little bit of Double Dragon 2 while talking about computational chemistry and high throughput screening and data mining and machine learning. And Ben likes lots of data and then processing that data.
Oh, yeah.
Which is a fun domain. So yeah, if you guys have questions about energy, I don't know, storage, conversion materials, batteries, catalysis.
Yeah, or anything I can answer.
Yeah, I mean, we'll do our best while playing some Double Dragon.
We'll try our best.
Yeah, that's what we go for.
Oh.
Yeah, there's another boss fight.
Am I supposed to hit this helicopter? No, not really.
I never understood the backwards kick in this game.
Oh, yeah. I think there are people coming from both sides, I guess.
There you go. What is that, a grenade? It's so realistic.
Oh, yeah.
So did you play this on arcade or this was console?
Oh, what do you mean?
Like the stand-up arcades at a arcade type venue or like a personal home computer?
Oh, it's like a personal home computer.
Contra. My brain exploded already. No, we use a lot of big words, but those big words can be reduced. If you had to explain to a high schooler what you do, what would be your explanation?
About what?
Just your expertise, what you're trying to do. Why? Well, let's say you're going to tell the average taxpayer why they should give you money to do research. What are you going to tell them?
Gotcha. Yeah, we tried this actually for the young scholar program. It's for high school. What I did is like we are going to build something like what you see in Iron Man movie. Yeah, so Jarvis, right? So we have an AI assistant designing materials for us. Not necessarily like a suite, right? But anything that need a material.
Yeah.
Yeah, so I mean, it works for the YSP. We got a high school student joining us. Yeah.
I mean, yeah, people might not appreciate this, but like when you talk about putting elements on the periodic table together, so there's 118 of them, maybe 50 of those are readily available and usable.
Yeah.
There's a lot of different ways you can put those together.
Exactly.
My understanding is, well, like experimentally, it's really hard to do that, or at least do all of that.
Exactly.
So you try to do that in Computo.
Yeah, even computationally is almost impossible still. Like if you want to kind of brute force all possibilities. Yeah, you know, like in solid state chemistry, we have crystal structures. Yeah, so basically the state of art is not really to randomly blend atoms. Like we have some particular, you know, crystal structures we are interested in, like, and we do combinatorial chemistry on those crystal structures to begin with. Yeah, the hope is that if we learn enough crystal structure, we are able to extrapolate to new crystal structures. Like, you know, everything's periodic in crystalline materials, and so we hope we can find new patterns. Yes, I guess that's what we are trying to do nowadays.
I mean, so experimentally, more often than not, somebody finds something that works and then they beat it to death with slight variations. And so I imagine you're doing a little bit of that, but you guys are trying to find new things that haven't been found before.
That's the hope.
Yeah.
But it's hard. Yeah, so yeah, maybe we can finish. I feel like.
No, go ahead.
Yeah, exactly. Like I mean, what people do a lot is trying to kind of dope materials, like with a little bit change of the compositions. Yeah, so for us, it's gonna be a problem of, you know, what is the dopability of these materials, for instance, like how much concentration you can change to these materials and what's gonna happen to the properties.
Oh, right out the window.
Yeah.
This guy's brutal. I mean, so the doping thing is interesting because it's, those of you not familiar, if you take a crystal of silicon, it's not particularly conductive or useful, but you put a little bit of phosphorus or a little bit of nitrogen or boron in there, and all of a sudden it becomes a semiconductor.
Exactly.
And now you have transistors, you have solar cells, you have LEDs, and it's a small, like 1% doping. It makes a huge difference.
Yeah, exactly.
And so computationally, you could endlessly play with the amount of doping and the different types of doping. So how do you narrow down the scope of the problems you try to look at?
Yeah, typically, like, I mean, there are a few types of ways to do this. Like, for instance, in your example, like, sometimes they're driven by a property. Yeah, so people always call this like a structural property relationship, right? So basically, we kind of sample, you know, a few doping concentrations and things like that, and then we're trying to come up with a series. In a lot of situations, it's like a phenomenological theory. Yeah, but it's good enough so we can kind of predict the trend.
Yeah.
Then that's basically when we can stop the, you know, simulation or experiment, and then we can be very predictive, right? Yeah, I guess we got a question.
Yeah. I'll go through that. You focus on gameplay.
Well, I have infinite life. Right?
Yeah, exactly.
Yeah.
That's fair. I mean, that's one thing I tell my students is like, as long as you find a pattern, as long as you find a trend, even if it's empirical, it has predictive capacity. Just find a way to draw a straight line between several points.
Yeah, exactly.
And you can predict something. And so ultimately you try to tie that to some foundational theory, right?
Yeah,
but sometimes it doesn't matter. Like, sometimes it's good enough, right?
Yeah, exactly.
All right.
Wow, this question is so long.
Contra cross-sticks. Contra. We'll be playing Contra a little bit later, so stick around.
Sure. Yeah.
Contra cross-sticks. Are the new computational tools helping with the study of crystal structures a great deal? I would imagine that it's an exciting time because so many fields seem to be exploding. Also, I read a couple months ago about a new watch-sized battery that's being developed that had many years of use. I don't remember what it was called. Is that real? So let's start with the first half of that. So are computational tools helping with crystal structures? Predicting crystal structures, maybe?
I think so. Yeah, that's my daily life, basically. Yeah, most of my paper is about, you know, like we kind of found like a few hundred or few thousand of new materials with certain crystal structures. And we kind of a joker. This kind of paper always have certain pattern. Like let me talk with my friend who does synthesis. And hopefully, some of them can be made and demonstrated. And if we are really lucky, we got really a good performance. Yeah, so that's basically like a first year, second year PhD project in my group.
I mean, so that's inorganic crystals, right?
Yeah, inorganic crystals also, we start with some hybrids already. I always get confused about the organic molecule names.
Yeah.
Yeah, but it's a lot of fun. Yeah.
Yeah. I mean, my understanding of the field, like inorganic crystals are a little easier to predict than organic crystals, like in terms of packing and things like that.
It actually depends. Like it's kind of funny, because now I'm doing hybrid material. I feel like people in both fields claim it's harder.
Do they?
Yeah, exactly. Yeah, there are different reasons. I mean, I remember for solid state chemistry, people typically inorganic crystals. I think the typical argument is that we have basically most of the periodic table.
Yeah.
And it's more or less, it's not like kind of like organic molecule dominated by carbon and hydrogen. Yeah, so that's typically the argument. We have a lot of crystal structures as well. And also for organic chemists, which I'm less familiar with, but now I start to realize, for instance, in those databases like CSD database, there are almost infinite organic molecules.
Not just that, the same molecule crystallizes different ways.
Exactly.
Yeah.
Infinite polymorph and things like that. Yeah.
Counter ions and salts and...
Yeah, to give some number, I think ICSD pretty much inorganic, and they have like 150,000 compounded node experimentally.
Jeez.
Yeah, organic, I think it's like 1 million, right? So,
yeah.
So it's like 10 times more. So.
And going back for the audience, if you guys aren't familiar with this, a lot of the drugs that you take are crystalline form of certain molecules, right?
Exactly.
But what's the thing that we learned through trial and error is that some crystalline polymorphs, like some ways the crystal grows, are completely ineffective. Like they just don't dissolve right, they don't deliver to the body right, and then other polymorphs are. And so they found this out like empirically, like FDA would approve a drug and you can deliver the same molecule, but if the crystal is different, it doesn't do the same thing. And that's crazy to me.
Exactly.
That's a lot of like Rob Sherko predicting.
Oh yeah.
Polymorphs in crystal.
Exactly.
All right, so second half of that question, I also read a couple months ago about a new watch-sized battery that's being developed and had many years of use. I don't know what it was called. Is that real? Are you familiar with?
Not so sure about this battery, but I mean the state of art is like if you keep an eye on those like Nature and Science paper, like every 1 month, there will be a long life cycle batteries coming out.
Yeah, a fast charge discharge battery.
Yeah, exactly. I even contributed to some of them.
Well, I work in the energy sector too, and I'm gonna give a disclaimer on all this because, like, every week we have a cure for cancer too, right? It's like some specific detailed cancer, and so a lot of these, I mean, 99 point whatever % of battery reports will never be useful batteries. And that's the reality, and they'll be good for a specific thing under specific conditions. But when you have to manufacture it, you have to encase it, you have to sell it to the public, you have to have supplies, you have to synthesize it on scale. Like, it's hard.
Yeah, exactly. It's a long way to go.
Yeah. So be skeptical, but all those progresses add up to new batteries and better batteries. So.
Exactly. Yeah.
You contribute to it. The press release.
I probably contribute to the good part.
Oh, man. We contribute to both, I promise. We accept that reality.
Oh, yeah.
Okay, the company is called Betavolt. They're in Beijing, and they say they're doing it with nickel-63 isotopes.
Isotopes?
Yeah.
Oh, I definitely believe nickel, but not so sure about isotopes of nickel.
Yeah, I don't know why that would matter, right?
Yeah. Will that be actually dangerous because of the isotopes, radioactive?
It depends if they're radioactive decay, but would it affect the actual properties?
I don't think there's any...
You gotta jump across.
Yeah, I don't think there's any influence, actually. It's more like redox. Yeah. I don't think the isotope changes the redox. And also, nickel is very expensive nowadays.
Yeah, it works via decay. Oh, that's interesting.
Interesting.
I don't know how they get energy out of that. I mean, so if you look at like satellites and like Mars rovers, they actually use radioactive decay to heat thermoelectrics to generate electricity.
Yeah, but for batteries, human carries that, right? So typically we don't like radioactive things.
Yeah. I'd avoid it in general.
Yeah.
But that's intriguing. So they're calling it a battery, but that's not really a battery, I guess.
Maybe like new concept, I guess. Like nowadays there are at least like 10 types of batteries.
Yeah, and Contra, the other thing and disclaimer I'll give, and this is a problem across, is if the private company is doing a press release, it's very different than a peer-reviewed publication. Because press release, you can say whatever the hell you want and claim whatever you want.
Exactly.
And it may affect shareholders and things, but it's not necessarily a legitimate contribution. So
Yep.
I'd just be skeptical. Not to say the idea is not viable or it's not interesting, but there's a lot of perpetual motion machine patents out there.
Exactly. Like nowadays, like especially because one fun fact is like there are infinite startups for batteries nowadays.
Mm-hmm.
It's also every 1 month you're gonna see a new startup.
Yep.
Yeah.
This is gonna be a.
Nice. I'm trying to understand what is that.
Oh, that was beautiful, Joe. Oh, no, now you gotta do it over and over again.
Oh god. Okay.
Yeah, Contra, you are right to be skeptical. I mean,
Yeah.
I've grown so cynical with the catalysis, and people can turn CO2 into methanol, and like it's been claimed for 30-some years.
Yeah. Exactly. It's coming back, right?
Yep. Yeah. And I think the big thing I'd say, if anything is truly useful, it will make it to the marketplace within a 10 to 15 year window.
Exactly.
If it doesn't, there's something inherently wrong with it. Either it's the science or the production or whatever it is. There's no conspiracy trying to stifle innovation. If it can sell cheap, it's going to sell.
Yeah, exactly. Yeah, I think compared with catalysis battery is kind of cheap enough. You know, it can be cheaper, but we are dealing with nickel and cobalt rather than platinum, so not too bad.
Yeah, that's fair. I mean, so how do you handle it when you see these press releases for new battery materials? Do you look into them at all, or do you?
Yeah, it's, you know, like the field is not that big, so we pretty much know everyone. So I just check if I heard of this name before or not. Like if I haven't heard about this name, so I will be. I mean, it's not impossible, but you know, it's less likely if they haven't done any research on that.
Yeah.
Yeah. So, maybe I'm too subjective on that.
It's a lot of data. Yeah, Contra, we have the same issue. Like, it's frustrating to wade through all the content. The number of solar cell papers published in any given week is like in the hundreds. And it's just, you can't keep track of all of it.
Yeah, exactly.
So you kind of see what floats to the top, what's interesting to your direct area.
Yeah. One interesting fact for battery compared with solar cell is like, you know, the synthesis it's not hard at all, actually. There's a fun fact in China, like a small city with a population like Tallahassee, for instance. You know, China has a lot of population.
Mm-hmm.
So a city with a Tallahassee population is really small in that case.
Mm-hmm.
Yeah, in that kind of a city, there could be like 10 battery companies. Yeah, because starting a company with battery is actually not so hard compared with solar cells and many other things. Yeah, because, you know, the battery materials are typically earth-abundant minerals.
Mm-hmm.
Yeah, so for instance, garnet, for instance, if you go to Macy's, there are all types of garnets. There are cheap ones and expensive ones.
Mm-hmm.
Yeah, there's a company in NASDAQ called QuantumScape. They only sell one type of battery material, which is from garnet.
Mm.
Yeah, garnet is like silicate, you know, it's everywhere.
I mean, the other part of that's worth noting is that like the measurement of batteries is relatively easy, right? You need a potentiostat. You need to measure electrical current and voltage relationships.
Yeah.
But
and synthesis is I would not call it easy, but actually the equipment does not cost too much. Actually, if you do the conventional way, you just need a furnace. And then buy a bunch of like solid oxide, which typically is not that expensive.
Yeah.
Yeah.
And grind a bunch of stuff together in different ratios till.
Yeah, exactly.
Cross your fingers.
Yeah, hit and bake. Yeah, this is extremely hard to predict actually. So yeah, so when I do presentation conference, I typically start with whatever machine learning model and DFT result I got, and then I gonna jump to the dark side, which is experimental results. Sometimes agree with experimental, sometimes it does not, and then we have to explain why it doesn't work.
Yeah.
Yeah, so that's actually a lot of fun. We'll kind of joke it as like going to the dark side. I typically have a transition slides for that.
I mean, but it's nice in terms of like funding. If you propose something, you have to have some kind of support behind the proposal.
Oh yeah,
You give that support, right? That's
I suppose so.
you try to.
Oh yeah, yeah, we make friends like that.
Only if it works.
Yeah. Oh, I should go.
Oh, nice.
Should I go up?
I think you're trying to get to that door up top.
Oh, I
right
think.
here.
Now I realize. How do I get up?
So I think you had it right. I think it's jump on this, then this.
Oh,
Then I
I
think
see.
you can jump on top of those yellow.
Gotcha. Now I got it.
It's been a while since I played this, so it's a grain of salt if anyone knows. We have backseat gaming on this stream.
I think I can do that within like 100 times.
High throughput.
Yeah, we can have to put this solution.
Trial and error. There we go.
There we go. Oh, nice.
Oh, nice.
Wow.
The double kick move.
Oh, I didn't realize.
Yeah, that's a great one.
Yeah. All right.
Contra's got another one. Follow-up question. Contra says, I'm going to phrase this wrong, but I had a lot of thoughts for years about using potential energy and gravity or orbiting bodies somehow, like how clocks work, where you pull a chain and raise a weight, and then the weight's potential is ticking the clock all day. Is it viable doing that with really big rocks? Potential energy storage in terms of gravity. That's interesting.
Yeah, interesting question. Like, we have to store the gravity potential. In that case, you have to go to high enough altitude, right? So
Yeah. I mean, arguably, that's what hydroelectric dams are doing, right? They're utilizing gravity in terms of energy generation.
Yeah, exactly. Yeah, that's a good example.
Yeah. I mean, the fun solar equivalent of that is solar thermal, where you take the solar energy and you store it in some kind of liquid. So you'll sometimes see these solar thermal farms where they like focus sunlight on a heating bath, and they'll heat up a liquid and essentially store the energy in heated liquid. And so there's examples going back hundreds of years of people like warming their houses at night through this mechanism.
Oh, I
Cool.
see.
But yeah, Contra's talking about doing that with gravity.
Gotcha. So that's the solar energy to heat.
Yep.
In that case. Gotcha.
Yeah, it's they call it sometimes solar thermal storage. But yeah, you can find companies that do that right now. It's hooking up, heating up an oil, and you can actually take those oils and you put it across the thermoelectric and generate electricity. So you're basically doing photons to heat to electricity rather than photons to electricity directly. So
Interesting.
yeah. Gravity batteries then.
Yeah, I mean, battery does not care about the source of energy.
Yeah, exactly.
Yeah, it just needs to be electricity. Yeah. In that case, yeah.
Storing it in gravity.
Sounds interesting.
So how's the gaming going?
I think, I mean, I have infinite life anyway.
Yeah, I'd be curious.
Yeah.
You watch the video and count the number of lives?
Yeah, I'm picking up my like childhood memory.
Yeah.
Yeah.
Well,
I think I only played 2 when I was a kid, actually.
It was this one?
Yeah,
Did you ever beat it?
I don't remember actually because I have limited time to play in my neighborhood's home.
Yeah.
Like,
Do you remember your neighbor's name? Want to give him a shout out?
oh, the thing is like I don't call him by name. I call him like little uncle or something like that.
That's fair.
Yeah.
Oh, this is going to be fun.
Oh, this one. Oh, I see. There's a loop here.
Gravity storage. I mean, the other one that we harness gravity with is like wave energy generators, right? Like in the ocean. That's essentially using the moon's gravity to generate electricity.
Exactly.
It's not on demand necessarily, but
Yeah, I'm also thinking about that. Florida have a lot of ocean power. Also a lot of minerals from the oceans, and so yeah, the cool thing for something like energy storage is like we're literally using everything around us.
yeah, anything we can, right? We don't
Yeah,
care.
we have to be earth abundant
Yeah.
because we don't want to pay too much for the battery in your iPhone. Yeah, so this is not so easy.
No, this is. I remember this part. Somebody else played Double Dragon on stream, and I think this was the part that really got him.
Oh yeah. Wow.
Thankfully, infinite lives. What is it? 4 lives if you play without?
I think it's 3, right? So, but we have those kind of chances. It's more like 3 multiplied by 10, I guess.
Yeah, the damage meter.
Yeah.
Yeah.
Oh.
I mean, so regarding the battery discussion, do you have an electric car, or have you thought about electric car?
Yeah, very good question. I think the problem for electric car is like, first of all, they're typically more expensive now.
Yeah.
Yeah. And secondly, like if you want to drive for a long mileage, it doesn't really work so well. You have to stop for like half an hour, 1 hour to charge it. Yeah, so because of that. And also another important thing, the gas in Florida is super cheap.
Yeah. Yeah.
Yeah, it's much cheaper than California, for instance. Yeah, a lot of people driving electric vehicle in California, but not so much in Tallahassee, as I realized. Yeah, so, but I'm actually looking forward to it. Like, a lot of cool cars now have electric a vehicle version, like electric Hammer. Like also many, I think all cool like American cars, there's now an EV version of it.
Yeah, I'm looking forward to. I think the next one Debbie and I get is going to be an electric.
Oh, I see.
That's going to be our goal at least.
Gotcha. Yeah, do we have enough chargers here? So that's another question.
And there's a bunch of Tesla chargers in the area. I don't know about just generic. I don't even know. Do they all share the same charging outlet? I imagine that's proprietary too.
Good question. I'm not so sure actually. I think yeah, I haven't owned an electric vehicle myself. Like, so I don't know actually.
This platforming is right. This is not Mario. This is pretty brutal.
I hope I can skip this.
The hitboxes are terrible. Sorry, Contra, you gotta watch this. Ask more science. Ben's on top of it.
Oh yeah.
Jumping platforms.
I'm only gonna do this for another half an hour.
Don't worry, we got a rage emote. Oh man. Oh, it's brutal too. I remember this just being so annoying because the platforms.
Oh, it's like 3 seconds.
Yeah.
Oh yeah, and the next one doesn't show up in the until the last second.
Yeah.
Okay, so I'm gonna focus and give it a try.
All right, do it.
All right. Oh no.
And that's the worst part. Now you got to wait for like 6 seconds for it to cycle through.
Oh yeah, exactly.
And then you got to go do it again and again.
Oh no.
Classic gaming, I tell you.
Yeah, I'm not sure if I can skip this, but anyway, let me try again. Oh no. And I cannot skip the stealth.
No,
right?
I think you got to do all of them.
Oh god.
If you want a break, I'm willing to give it a try.
Oh yeah, if you want.
This in a long time, but I play a lot of Mario, so maybe that'll help. Nope.
Hopefully.
Which jump button is it? It's B?
I think both of them. A and
Both
B.
of them?
Yeah. Then I can focus on answering questions.
Wow. That's brutal.
Oh yeah.
And then he lands on a knee when he goes down too. What an annoying mechanic.
Oh yeah, we have to jump in the last second.
Yep. That's the worst.
Nice. Oh,
Too early.
Yeah.
And that one you don't even want to go forward. Oh, Contra has another question. It's a rhythm game now? Yeah, this is
oh yeah.
Dance Dance Revolution Double Dragon version.
Infinite jump.
We do one more before I try to get to that question. You got to go like earlier than you think you have to. It's super annoying. All right, Contra has a question. More science. Trompe technology is quite ancient. Trompe? Interesting. And uses falling water to increase air PSI of a reservoir. Saw a guy blowing up his driveway with one of the high pressure release valves didn't work. Oops, that was an anecdote. Uses falling water to increase air PSI above a reservoir. I'm not familiar with that. That is interesting.
Yeah, sounds interesting. Yeah.
I mean, I like that. What's the fan cooling system on computers where you have small openings and it allows faster airflow through the small opening? That's a cooling mechanism.
Yeah, like air conditioner. That's how it works, right?
Yeah. And it controls it through the flow. Are they all the same timing? It looks like it, right?
I feel like this one is a little bit faster. Yeah, the one after the one just
That
jumped.
one's faster. Man, that's brutal. Oh, too far. This guy's got too many hops.
Yeah.
Mediocre gameplay, ladies and gentlemen. We apologize. Because you fall before it disappears. It's really weird and annoying.
Oh yeah. Yeah, I feel this one you have to jump a little bit like late.
A little more time.
I think you are perfect in the first two.
Yeah.
Yeah.
And then just wait a little bit on the third.
Yeah.
I'm just using this as an excuse to play video games, ladies and gentlemen. Oh, I didn't go forward.
Yeah.
I didn't look at the speed run of this game. I should have.
Oh.
Because does he jump the same distance every time?
I think you can control. Yeah, by the forward button.
Like it's different distance depending on if you're pressing forward or not. Sorry, I'm playing with the jump button.
Do you think we can jump directly from here, just upwards?
Doubt it.
Oh, I see.
They're so ruthless in these games. They won't give us that luxury.
Gosh. Oh.
I got too antsy. No.
Yeah.
Oh, I got selfish there. Progress, exactly. We got
Exactly.
a third platform. We take that.
50%.
This is the great equalizer. It's all about rhythm, which I don't have. Do you ever play any of the Dance Dance games or the like Guitar Hero or any of those?
I tried to, but I realized I'm really bad at those games. Yeah.
So you didn't play a musical instrument when you were young?
Oh yeah, I realize I'm very bad at that.
No worries.
But I'm happy to try. Like, yeah. Oh, nice.
No! Oh, God.
Rage.
Rage. So close.
Yeah.
We got this. We need to beat this game tonight. Oh!
Wow.
All right. Woo!
Yeah.
We'll take that, ladies and gentlemen. We grinded through
Thanks for the ride.
Team effort on beating Double Dragon 2 tonight.
Exactly.
So, congratulations.
All right.
Oh, God. It's even worse. Oh, this should be better, right?
It should be better. I think I can do that.
Yeah.
Just 10 more try.
All right. If anyone has questions for Ben, he's happy to answer them.
Yeah,
Anyone
yeah.
just joining us, Ask a Scientist Gaming, mediocre gameplay. We're living by that one tonight. Expert science, though. We're talking about computational chemistry, battery materials, high throughput, data mining, machine learning, processing information for energy storage materials, whether it be batteries or catalysis or... Yeah, so you talked about diving into the world of organics. What are you working with hybrids?
So far it's like, like organometallic. I recently learned it should not be organometallic. It should be like organic metal halide hybrids.
So like
Because of the
stuff.
because of the ionic bonding.
Yeah.
Yeah, I realized that.
So I think the formal definition of organometallic is it has to be a carbon metal bond.
Oh, exactly.
Yeah. But even the journal Organometallics, I don't think adheres to that.
Oh, I see. Like there are people like didn't follow that.
Yeah, I think sometimes like metal ligand systems that aren't carbon bonded,
I see.
they make it through.
That's interesting. Like, those kind of rules and nomenclatures are, for instance, like in batteries, people call Prussian blue organic,
Oh, interesting.
which is really weird.
Prussian blue, that's iron cyanide.
There's no hydrogen here. There's crystalline water. I'm not sure if that counts.
Yeah.
I literally see many paper calling PBA like Prussian blue like organic.
Yeah.
Yeah, that's really funny.
Carbocentric folks need to meet the aliens. Silicon-based aliens.
Oh yeah.
What do you think, Ben? Do we have silicon-based life somewhere?
I'm not sure. Zeolite.
Yeah.
I realize zeolite probably gonna be the origin of silicon life. Yeah, because it's pretty much like organic world. There are infinite zeolite. Yeah, and you can make polymers out of it actually. And I mean, there are super large pore of zeolite. Yeah, we're actually recently looking into it because again, polymer is too hard for me. Silicon dioxide maybe not so hard for me.
Yeah.
Yeah.
So when you say zeolite, what's the broad definition of zeolite? Do you know?
I think typically if you have something porous with a crystal structure and with silicon oxide in it with different stoichiometries, technically you can call that zeolite.
Oh, I see.
Yeah, and then typically people go with aluminum, and there's such saying that your aluminum and silicon ratio cannot pass like 1:1. So I think it's very difficult to have more aluminum than silicon in a lot of zeolite. But I'm not sure if this is still true. I saw that in a 1970s paper. Yeah, so
I don't know what's going on here. So if you just drop down, you die, right? Like you have to jump, otherwise yeah.
Yeah, this one is super fast, and the last one,
Yeah.
not so sure.
All right, the Dark Angel coming in with a factoid. Did you know a snart is when you sneeze and fart at the same time? A random fact you never wanted to know.
I guess I got
Did you think you were going to learn that one tonight?
that's my biggest learning skills this night.
Yeah, no, that one will stick with you. You get your fed factoids from the chat.
Yeah.
You Dark Angel.
Thank you.
Fun factoid. Here I've been calling it reverse burping. No, Contra, clearly you're wrong. Check your IUPAC definitions of nomenclature. It's a snart. I don't know if that's true or not. Misadventures, welcome back. Thank you for joining us.
Yeah, welcome back.
Yeah, we got another theoretician on, this time computational chemistry, data processing, big data processing, using large data sets and computationally processing a lot of materials at once. So trying to do high throughput where you can't do it in lab.
Oh yeah.
How's it going?
I'm trying to figure out how to work on the last one. Like,
Yeah, I think you got to like run against it because I think it's a fixed distance jump every time. So you have to like jump from this side and then try to go there.
I see. Maybe yeah,
because this one you have to like jump from the middle, and then that one you have to like run back that way.
I see. You mean the first one have to jump in the middle?
Yeah, jump from the middle. Yep, and then run back that way and turn around and jump right away.
Oh, I
Yeah,
see.
there we go.
I see.
Snart. Dark Angel coming in strong with a snart.
All right. Should I skip this one or maybe jump on?
No, I think you have to do it. This is one of those games. If they wouldn't have included it unless you had to do it.
I see.
But I think you got to jump.
Oh,
Progress. And then the last one, I'm assuming you just have to run to the right and jump at the last moment.
gotcha.
Ooh, fireworks. Did you hear that?
Yep. I think tomorrow is Independence Day.
Misadventures asking the important questions. What are we drinking tonight? The answer is Proof La La Land American Indian Pale Ale.
Exactly.
So you can kind of see it. There's a link to Beer Advocate. But yeah, this is Proof is a local company in the Tallahassee area. They exploded over the last 10 years or so, and they're supplying, I think they're out of state now, actually. They're distributing everywhere. But yeah, very popular local brewery as well as bar that people go to.
Is Ology also local? I didn't.
Yep, Ology and Proof are two in town for sure.
Gotcha. There's a coffee shop.
Yep, yeah.
Yeah.
The Ology, the one right off Monroe.
Yeah,
Yep.
exactly. That's so cool.
Yeah. Oh, that's fun. Proof, I guess a lot of students go to the Proof one.
I guess so. Like I went there a lot.
Yeah. It's fun. Contra, Zeolite's pretty and quite varied in their appearance. Yeah, Zeolite's, my understanding is it's a crystal lattice, right? Like it's normal.
Yeah.
It's like
it's a lot of. It's more like an inorganic polymer. I would like to think about it in that way, with a crystal structure. In that case, polymer also have a crystal structure.
Contra. Thank goodness no more rose liqueur. No, it was rose tequila is what we drank last time.
Oh, yeah.
I don't know if you were watching, Ben, when we busted that out.
I saw
oh my God, that was such a terrible thing, and it was terrible.
Oh, really? It looks like you enjoyed it.
I mean, we were having fun at the time because, there we go. Oh!
Okay, I almost know the trick.
Yeah, I think if you get to the end of this one and jump.
Exactly. Now I finally know it.
Yeah. This is what it's all about. God, that was terrible, but you guys should definitely try the rose tequila. Next faculty party, should I bring some?
I think so.
You'll give it a try?
Yeah, definitely. People are gonna love it.
Well, with that said, I asked Ben what he wanted to drink, and he's like, liquor, but I have to drive home. So
Oh, yeah.
that's fair. Yeah, if I ever got a sponsor for this stream, what I'd pay for is everyone's Uber ride home at the end of the day.
Oh, that would be nice.
Yeah. Because it does kind of suck driving after. I mean, we don't have that many drinks unless it's like... Yes! Nice!
Finally!
That makes the victory so much sweeter, ladies and gentlemen.
Oh, yeah.
But yeah, if you guys have questions, ask Ben. He's beyond the jumping part. He can answer all those questions right now. He's ready to take on the hard ones.
Oh, yeah. Shouldn't be hard questions.
So the double tap, is that the tornado kick? How do you do that one?
Oh, you mean this one?
Yeah.
Oh, yeah, I think just A and B together and up and front, I guess.
Oh, forward with it?
Yeah. Oh, no.
Yeah, jump kick is working well, though.
Yeah, that
Woo! Man, we beat two hard parts on this one already. Teamwork, we're beating Double Dragon, ladies and gentlemen.
Oh, yeah. Oh,
Yeah.
I think I have limited time here. Oh, now I did it.
What is this nonsense?
Okay. Oh, it's
Oh,
coming
he
back.
didn't fall off the platform.
Oh, shoot. I think he's gonna fall ahead of me at least.
I don't know.
I don't know.
He's just gonna keep beating you in the corner. Or maybe it's done. Maybe you can't even fall off anymore.
Yeah, I think it stops. Okay.
All right, you're fine.
Yeah, I don't care anymore.
All right, Ben. So if you had to pick a favorite crystal or
Yeah.
crystal lattice type, I mean, there's a lot of different crystal and lattice material. We actually had a geologist on, Emily Stewart, fairly recently, who has her favorite crystals, favorite
Sure.
minerals. Do
Yeah.
you have your favorites?
It changes all the time, like I actually watched the episode with Susan actually. I think she mentioned there is a competition for that. Mm-hmm. Yeah, for favorite crystals.
What?
I participate in Twitter 2022.
Yeah, somebody was like, "What's your favorite crystal?"
Yeah, I think it's a competition between perovskite and sodalite.
Satellite.
Yeah,
All right.
yeah. I barely remember. Both Susan and me vote for sodalite. Sodalite is actually one type of zeolite.
Yeah.
And the reason why I like it is it's also a battery material, which is cool. Yeah, perovskite is a little bit too boring for chemists because it's everywhere.
I mean, it is now. Yeah, like perovskite solar cells, perovskite LEDs.
Perovskite battery as well. Yeah, also fuel cells and catalysis. Perovskite is literally everywhere. Superconductors. Yeah, so we cannot live without perovskite. Yeah.
Anyone that's not familiar, perovskite describes a class. You might have heard of perovskite solar cells, but what makes a perovskite is a a particular formula. It's called ABX, where you have an A component, a B component, and then you have an ABX3, I think
Yeah,
it is,
exactly.
right? And so you have 3 X's for every A and B, and you put those numbers together, and it could be organic materials, it could be inorganic, as long as it has those ratios and makes a crystalline lattice. I think it falls under the umbrella of perovskite.
Yeah, exactly. That's a quite interesting question. If we have carbon hydride in the A side and then metal halide, for instance, should we call them organic or hybrids?
I don't know. That's a good question.
Yeah.
Yeah, there we go.
Oh, yeah. Awesome. I think this door should open, right? So I'm not sure if I can get inside. Maybe I can. Yeah. Awesome.
Oh my god.
Oh, yeah.
We're jumping.
Oh, jumping all the time.
I mean, thankfully this one looks a little more forgiving because they pause.
Yeah, I think this is not hard. All right. Yeah, I think this is easy.
Too easy.
Yeah,
We'll see where it puts you if you die up here, though. Because if it makes you start over at the start, that's terrible.
No. Oh. I think it's not from the very beginning at least. All right.
Yeah, doesn't seem too bad.
Yeah,
You can probably walk off on this one.
I guess so. Too early to say easy.
Blast jumps don't look easy.
Oh,
Thankfully, the middle little ones aren't moving.
I think
So as long as you get in the right position.
Yeah, yeah. Okay. Just wait. Jump too hard.
Yeah, I think you got to jump from the back of that platform.
Gotcha.
Perovskites, they're everywhere. Yeah, I got sick of reading proposals and papers about perovskites. There's some good ones, don't get me wrong, but there's a lot of...
Yeah.
I mean, speaking of perovskite, so in the solar cell world, there's this huge problem of hysteresis where you measure it once and then you try to measure it again and it changes because the measurement itself actually changes the property of the material, or shining light on the solar cell changes its behavior over time. Is that true with perovskite batteries or batteries in general? How reproducible are they?
Good question. I think in solid state battery it happens. Yeah, like though I used to be part of a work when people use TEM to see batteries. Those garnet is like lithium, lanthanum, zirconium oxide. You're gonna like plating lithium metal actually when you just look at it. So with TEM, so they have to lower down the electron dose to get rid of the damage it caused. So I think the typical issue for solid state battery is like you don't want to generate a lot of lithium in the electrolyte. Otherwise there will be short circuit. So your battery is dead. Yeah, so I think it indeed happens, but for in terms of the light interaction with battery, I'm not so sure actually. Yeah. And one major reason that I'm not so sure is because my level of DFT theory is not so advanced to capture this excited state. So typically you have to go back to last week and watch Eugene's episode. Like you really need something post-Hutcherfolk.
That's too many atoms for Eugene. Too many atoms.
Oh yeah.
But yeah, I mean, for the solar cells, the light's obviously an issue. The battery's probably not so much, but ion migration can change the structure and change grain boundaries. And
if it's ion migration, then it's totally my field.
yeah.
But if you talk about something like absorption and excitons, and then I'm not so sure my level of DFT is good enough or not. Yeah, because in order to high throughput, you cannot afford very expensive DFT functionals. Yeah, so that's typically the problem. Yeah, we're good enough for redox and steady state, but not so much for an excited state. There's gonna be a lot of trouble.
That's fair. All right. While you're struggling with the jumping and landing and whatnot, we'll do one of our favorite questions. What's your favorite equation?
Oh yeah. When I was a postdoc, actually, my postdoc advisor asked us to fill out equations. Like, I think half of the group fills up the Arrhenius equation because we study diffusion. Yeah, I think that's my favorite.
Diffusion equation.
Yeah, the Arrhenius equation, like, because it has both thermodynamics and kinetics, it has Boltzmann distribution for sure, and also anything that follows, Boltzmann distribution, Boltzmann transport theory, you can use that to calculate conductivity, charge transport, or atomic diffusion, reaction rate, and things like that. I'm gonna teach that a lot in my PChem course, hopefully. So yeah, I really like it. That's basically the equation I use a lot. Yeah.
So you said it's the Arrhenius equation?
Yeah,
The modified Arrhenius.
We're definitely gonna modify. It depends on the exact problem. But I think the original form is simple enough, right? So yeah, I can take that one for sure.
Yeah.
Yeah.
That's fun. Yeah, that's one we teach in general chemistry too.
Oh yeah, exactly.
I really like Gen Chem too. That is, I really enjoy teaching it.
Exactly.
It's, I mean, kinetics, a little bit of thermodynamics, plus equilibria. Like that's most of what we do in the chemistry.
Exactly.
Whether people know it or not. That's dictates pretty much everything.
Yeah. As long as it's not quantum, it can be used to describe almost everything.
That's fair.
Yeah.
I mean, it explains a lot. Oh no. Can you explain what's sorry, catching up on a question here. Can you explain what's meant by iron migration? I have some interest in hemochromatosis and other iron deficiencies. Oh yeah, no, we're saying ion. Yeah. Powcat, thank you. Ion migration, moving ions, so charged atoms or charged particles, moving those around. So let's start with that. Like basic function of a lithium-ion battery. How does it work for those that aren't familiar?
Oh, you mean like how lithium-ion battery works?
Yeah. Just like why they work the way they do, how they store energy.
Yeah, it's pretty much like the redox potential. Like it's again general chem. Like I typically like joke that you just need general chem 1 and 2 in order to be able to do battery research, to understand battery at least.
Yeah.
I mean, you just need to have 2 electrodes with different redox potentials, and hopefully lithium gonna be the carrier of electricity, and then you can generate a potential, and that potential times the voltage, the potential times the current. You're gonna generate the energy density and the stores energy. So basically, that's how it works. So very simple. So literally you can use anything, but there's one particular reason why people end up with lithium-ion battery, because I believe lithium is one of the typical ions that have the lowest potential. Yeah, compared with, for instance, aluminum and sodium and things like that. Lithium is not that earth abundant actually.
Yeah.
But somehow in lithium-ion battery, you have the largest potential to couple that with typical transition metal and to increase the voltage. For instance, sodium-ion battery. Sodium is more earth abundant. You have infinite sodium in ocean, but the potential is relatively lower compared with lithium-ion battery. And of course, there are many other reasons, but I think the standard potential is one of the reasons of it.
Yeah, no, it's intriguing because you can have cheaper batteries, but they're just not going to be as good.
Exactly.
That's infuriating.
There are also iron battery, but it just works not so good.
So yeah, batteries have a really fun history. I teach this in Gen Chem, and it's just kind of a fun factoid. I don't know if you ever got to the electrochemistry chapter, but
yes, I do.
The origins of electrochemistry and batteries is pretty amazing because Galvani came along, and Galvani said he was basically, back in the day, you were a Renaissance person of sciences, right? So you do everything from anatomy to electrochemistry to blah blah blah. In the early days of electrochemistry, you essentially had like amber coils, and you'd start charging these like Leyden jars and things like that, and the Ben Franklin key on a kite kind of thing. But he was dissecting frog legs near one of these Leyden jars, and he basically saw that the legs twitched even though the frogs were dead. And so he was like, oh, this is intriguing. And so he started to study it more and more. And when you like hung them by different wires, you got different outcomes, different magnitudes of the flexing in the legs. And so Galvani basically described this as a animal electricism or something like that, or animal something like that. It was like animal-based electromagnetics. And so he was like, this is where electricity comes from. It's a force coming out of animals kind of thing. And Volta came along, and Volta said, I don't think that's it. I think it's the metal. And so Volta actually invented the battery to disprove Galvani. He basically said, if I put copper and aluminum stacks or copper and zinc stacks together, I can generate electricity without the need of a living creature. So yeah, that's the origin of the first battery. So he literally built a battery to prove someone wrong.
Yeah, I still remember I teach that last year.
Yeah.
Yeah.
Did you use my slides for that?
I believe I used at least a few of them. Yeah, I remember this story. Like you put that in your slides.
Yeah, no, it's such a fun one because you wouldn't appreciate, because he had no goal of like changing energy storage or anything. But yeah, he's just like, I'm going to prove you wrong and invent a battery.
Exactly. Yeah, that's cool.
Yeah, it's really fun. All right. One of the strong motivators? Yeah, exactly. If you want to get a... Oh, no.
Oh, no.
Yeah, I think you have to get to the right side of this platform and jump from there.
Gotcha.
But yeah, that's one of those things. You'd be surprised how motivated people are to prove others wrong. The saying goes, if you want to get an answer on the internet, don't ask a question. Post the wrong answer and somebody will correct you. Oh, what the heck? Where's the OSHA safety code on this particular place? How are you doing on beer? You're good?
I didn't finish this one yet, but I can definitely take another one.
Yeah, just let me know whenever you want.
Sure.
All right, so we're an hour in. You want to keep playing this?
Maybe I can try this again for another 5 minutes.
Thank goodness for ChatGPT. Now I can be sincere again on the internet. ChatGPT is an interesting monster. Any opinions on ChatGPT?
Yeah, I think many people use ChatGPT to do chemistry nowadays, right? So I saw a paper from Ouyang recently, like he used ChatGPT to design, morphine cough.
What?
Yeah, it's actually not that bad.
Yeah,
you have to feed a few papers to ChatGPT at least.
Oh, I see. So he used his own training data set then. It's not the broad ChatGPT.
Yeah, exactly.
Not the one that has the gutters of the internet.
Yeah, you definitely have to train it a little bit.
Yeah. So he just took all the moth papers, trained it a generative AI of some kind.
Yeah, like just a large language model, I guess. Yeah. And it's actually not that bad, actually, nowadays. Like, the cool thing is, like, there are actually a lot of low-lying fruit, because, what AI is good at is to look for the relationship between different compound, for instance, even the name of the compound. I think when I was a postdoc, one of my colleagues did one thing for thermoelectric material. So now recently there's a paper on it actually. About 10 years ago, people didn't realize topological insulator typically are very good at thermoelectricity. So nowadays I think it's probably well known already. I'm not in that field. But then when you use natural language processing, the algorithm gonna figure out that actually very quickly. Yeah, so there is a paper in Nature 2016 who read all the papers of thermoelectricity about in the past 20 years, and that paper, and then we use NLP to predict the new materials. And then, what does the algorithm do is basically look for the abstract and to check if there's any keyword related to topological insulators. And eventually the algorithm can really identify, they learn all the literature, for instance, before 2008. And then they can predict some compound that has been discovered, for instance, in 2012. That actually works pretty well. It's low-hanging fruit, like a smart PhD student gonna eventually figure out that himself or herself as well. But but this is more like a automatic or maybe like a high throughput way. You just use a computational algorithm.
I mean, so correct me if I'm wrong, but my understanding is, like, if you're going to do machine learning and apply that to some data set, like the Crystal database, your fundamental limitation is having like a usable large data set, right? That's interpretable by the machine learning algorithm. Does ChatGPT help you do that? Can you translate from common language to a usable table? I mean, are you or are other people doing that?
That's possible, actually. There are very mature algorithms doing that. So we did that for solid state synthesis before. Like There are actually very mature algorithms to, for instance, a typical question to read the literature is like when you read a chemical reaction, what will be precursors, what will be, the product, what's going to be the catalysis sometimes.
Yeah.
Yeah, there are ways to do that. Like this is essentially what NLP does. You're going to figure out the word after a certain word to decide, whether this is something added into this reaction or this is something produced by the reaction. So we have done that for solid state reactions like shake and bake. It's typically we shake some metal oxide together and bake it for certain hours. And XRD tells us we formed something. So this is a typical story. It's actually not bad at all. Yeah, so now there is a database for inorganic synthesis is actually available, open source. It's a collection of like 5 million solid state reaction papers.
Jeez.
Yeah, like a human being cannot really spend a few months to read all of them, right? So,
Yeah.
yeah, but like a large language model nowadays, can do that very simple. But the problem is like you have to pay for tokens to use ChatGPT if you really want to read like millions of paper.
Yeah.
Yeah, that gonna cost you a lot of money for that.
That's fair.
Yeah, and GPU is not cheap.
Yeah.
Yeah, so that's the problem.
It's absolutely fair.
Yeah.
How's this level going?
Yeah, we solid state chemists joke, ourselves like we're doing shake and bake experiments.
Yeah.
Yeah.
Contra, that's a classic. Shit, like my undergrad RU project was making metal organic frameworks.
Oh yeah.
It's such an easy thing. Like just put things together, put them together in different ratios till you get a crystal.
Exactly.
And then you have a useful material. And
Yeah.
it's so much trial and error, which is why we call it shake and bake. But put stuff together and hope you get something useful out of it.
Yeah, that's why like the organic thing will be very useful. Like there are a lot of design here, and in shake and bake, like there are definitely science behind, but we don't understand so much for now. Like for instance, how much you bake gonna make a huge difference sometimes, and how do you shake actually also make a big difference. But there's no theory or direct simulation tools to really model that. Yeah, so that's why I think maybe that's something I can do in the future. Like that's the inorganic retro.
Yeah. Oh, that'd be incredible if you could.
Yeah. I guess I probably need some teamwork.
Yeah, you
Would
want
you
me to
mind?
give it a try?
Yeah, thanks a lot. Yeah.
I'll give it a shot. I mean, this one's like a... Oh, come on. That's not even fair.
Oh.
It's because the jump is so delayed. It's annoying.
Oh yeah.
Because you can't do the full jump, can you? No. I think the key is just falling off this one, right?
Yeah, and you work a little bit.
I uppercut. I don't know if I can do this.
Yeah, maybe
Oh.
maybe we can switch game afterwards.
Yeah, what do you think? What do you want to do next?
Yeah.
Contra?
Yeah, maybe. Yeah. Contra have less jumping. Right?
Whoa. Yeah, Contra has...
I like shooting all the time.
Fair.
Oh, that works. Awesome.
Ah,
Oh,
did
nice.
it. All right.
Wow.
All right.
Thank you.
We'll survive. We're beating
Yeah,
this game.
lifesaver.
We have
Yeah.
to commit. To be fair, I've played a lot of games recently.
Contra is a jack. Don't do it.
Love Contra. Contra is classic.
Oh yeah, definitely.
Contra is a hack. Don't do it. Absolutely not. Contra is one of the all-time classics of NES. All right, but if you guys have questions, we are just crossing an hour on Ask a Scientist Gaming. Mediocre gameplay, expert science. Not so mediocre sometimes. We're doing our best here. But we are trying to beat Double Dragon 2 tonight while talking about battery materials, energy storage materials, data mining, machine learning, processing big data sets, ChatGPT, all sorts of things, wherever the journey takes us. Ion migration, batteries, the history of batteries. We've gone all over the place tonight. So if you guys have any questions about anything related to any of that, Ben is happy to answer them.
Yeah.
We can brainstorm.
Or anything that you think I can answer.
Yeah. So I got a fun one for you that I'm doing right now. Is actually, so we just got our paper accepted in Journal of ChemEd where we can identify ChatGPT usage on a multiple choice exam.
Oh.
Which is kind of weird, right? It's single letter answers, but we can do it pretty successfully.
Oh, that's awesome.
One of the things the reviewer asked is like, why does ChatGPT get certain things right and certain things wrong? And so something my collaborator is doing right now is me and my students are going through all 980 questions we gave across 5 years, and we're identifying characteristics of those questions. Like, does it have a formula? Does it have a calculation? What level of Bloom's taxonomy? What level of knowledge?
I see.
And then he's going to apply like a machine learning algorithm to basically see what behavioral patterns ChatGPT has versus students.
I see.
What is ChatGPT good at? What is students good at? And we just kind of want to see what trends fall out of that data.
Gotcha.
So that should be kind of fun.
Yeah, I think algorithm is more predictive.
Yeah.
That's probably a short answer to a review question. Like, yeah, because we also see something like in materials prediction, for instance, like the deeper learning you go. Like deep learning is basically when we use very complicated neural network to predict something equivalently complicated in chemistry. So the funny thing is like deep learning is super good at get a certain distribution, but when you change the distribution a little bit, the machine learning model gonna suck at it. Yeah, so I mean, similarly for like ChatGPT for doing exam, I think if they make mistakes, I think there should be a well-defined pattern behind it.
Yeah, it'll be curious because there's subtle things like if you change the word oxygen to O2, it'll get completely different outcomes. Sometimes it's right, sometimes it's wrong.
Oh, I see. So yeah. I guess that's probably the algorithm. They think O2 and oxygen are different things.
Yeah.
So that's
depending on the training set, I imagine.
Yeah,
right?
exactly. Yeah, we have something like that in crystal structure. Like recently, I asked my student to look into that. We have this kind of thing of equivariant stuff. You know, like in crystal structure, when there's a translational symmetry, right? So when you move all atoms at the same distance, they are the same structure. But machine learning doesn't know that. So effectively, a terrible machine learning model, you have to rotate the crystal structure in many ways to teach machine learning that this is the same thing. It's just like a cat. You have to take a picture in front of the cat, behind the cat, on the left-hand side of the cat, the right-hand side of the cat. So the machine learning gonna know, oh, this is a 3D cat.
This is the same thing.
Yeah, so this is called invariant. So it sounds stupid, right? So you need like maybe like 100 pictures of a cat.
Yeah.
In order to really understand this is a real cat. Yeah, so there is some cool things. I think Eugene gonna love it. There are different ways of encoding that, just like quantum mechanics. They define orbitals of different shapes. You know, those orbital functions, they are like dumbbells, for instance, right? So in that case, you can preserve the symmetry, so it can be equivariant. In that case, hopefully you can encode a 3D cat with just one data, and then the machine learning model gonna know this is a cat. Yeah, so that's a very cool invention recently. Like I think the first paper came out like a few years ago.
I mean, so when you talk about processing these crystals, you're giving it the Cartesian coordinates of the lattice, or you're giving it like an image of the crystal?
Yeah, that's exactly the question here.
Yeah.
So, first of all, like you can literally give anything to machine learning model.
Yeah.
But the problem is like how effective it's gonna be. If you give a Cartesian coordinate, you're gonna have the issue I mentioned. Like if you shift all the Cartesian coordinate a little bit, machine learning model will not know what is that. Yeah. Because it looks totally different. Yeah. So then you have to encode that in a way, you know, it looks exactly the same. So that's the big challenge. And otherwise, another thing you can do is just to randomly shift it. And then machine learning gonna know that whatever you shift, the energy or the property is the same. Oh, interesting. So you don't just give it one X, Y, Z set. You give it a distribution of them, all positions. Yeah, or you randomly generate some variation version of the same thing. Yeah. And you... Yeah, it's like take pictures of a cat from different directions. Basically something like that. Yeah.
Misadventures in Astro wants to know, what's the big mystery or unexplored frontier in your area of study? So I guess this could come down to either the tools you use or the actual materials that you're trying to generate.
Yeah, I think so it's a very good question. So I think something we are working on right now for machine learning, like now people are really excited about, AI for science.
Mm-hmm.
Yeah, so especially like the so-called AGI, like it's like it's artificial general intelligence. It's like AI knows everything about chemistry, for instance.
Mm-hmm.
So, but there is also debates whether this is really going to come true in the near future. Like for instance, like ChatGPT know all kinds of chemistry knowledge. It can design battery materials. It can design, interesting molecules for photochemistry, for instance. So, but the challenge, also the mysterious, is like, are we really ready for that? We are actually writing a paper saying that we are not ready for that.
Yeah.
Yeah, because the thing is like, AI is super good at interpretation. For instance, like in a chemical space, you try a bunch of computations, you can guess the rest. This is something AI is super good at. It's more like a curve fitting, right? So, but if you ask the AI to create a new crystal structure, it's gonna be a lot of like funky stories.
Yeah.
Like it's gonna create a really, for undergraduate chemistry students, this makes zero sense, but the AI gonna create such kind of structure. So I think it's still some kind of a fundamental reason behind it.
Mm-hmm.
Yeah, so which we probably need infinite amount of data to really make AGI come true to science, or there should be some fundamental change to the algorithm. So I think that's my opinion, but this is still a mysterious. People are still debating on that.
Yeah, one of the things I tell my students, and we talk about this regularly, is like ChatGPT is an answer generator. Right? It doesn't care what answer it generates. It just wants to make a real-looking generator. That's its goal.
Yeah.
And there's this paper I read recently. It's published in the Journal of Ethics and Information Technology. I'll put a link there for you guys now. But the title of the paper is literally "ChatGPT is bullshit." And so the title is pretty inflammatory, but their argument is, I don't know if you've heard the terminology like ChatGPT lies or it has hallucinations. They're arguing that nomenclature should not be used to describe ChatGPT, because both lies and hallucinations implies that ChatGPT cares about truth or has an absolute frame of truth. Because in order to lie, you must know the answer, or to have hallucination, you must know what's real. And ChatGPT doesn't know any of that, right? It doesn't care. And so what it's saying is it's like an undergrad trying to do a book report on a book they haven't read. They're just making up bullshit, right? They're taking words and compiling them together in something that sounds real. So it was actually a really compelling argument. And it delineated between soft and hard bullshit.
I see.
Soft bullshit meaning just made up whatever word soup. Hard bullshit meaning it has an intent. And hard bullshit is harder to demonstrate because, like, what is the intent of ChatGPT? And if you argue it's to sound human, then it is hard bullshit, right? Because that's what it's trying to do.
Yeah, that's an interesting paper. I can definitely remember this name.
Well, my student gave this to me. I'm like, well, that's an interesting title, but it's a really intriguing read because it goes back to like 1980s definitions of like, what does it mean to lie? What does it mean to hallucinate?
Yeah.
It's a philosophical argument, but yeah, worth a read.
Yeah, that sounds like a very fair statement.
Mm-hmm.
Hey, it's more like an intelligent searching engine, I would say.
Yeah. It should be called ChatGPT as a lazy undergrad then. Absolutely. Did it mention philosopher Hank Frankfurt? I think it did. Frankfurt, let me see. Let me see if I can find it. Yep. It's in the abstract, actually. It's better understood as bullshit in the sense explored by Frankfurt. On bullshit. On bullshit is the citation from Princeton in 2005. So yeah, it's a fun one. This dude is treating you like an omelet, and you're getting wrecked by this guy. You should do the double jump, the tornado kick.
Oh yeah.
Use that bad boy. That's a good one.
I see.
Contra has a question. Sorry. Is that problem of trying to teach it 3D rotation somehow analogous to what happens when I try to imagine 4D as a non-mathematician, I wonder?
Oh,
interesting.
I didn't see all the questions.
So basically they're saying, like, us as humans, we have a 3D frame of reference, and when we try to picture 4D, we can't do it. So when ChatGPT is given Cartesian coordinates, it can't even comprehend three-dimensional rotation of that. Is that a reasonable analogy?
I mean, but Cartesian coordinates is 3D, right? So
yeah,
you still get a sense of it.
Yeah.
Even for high dimensional, that like you can always encode that with a tensor, right? So I don't see there is a direct mathematic problem on that. But the problem for human is like, but honestly, I think in chemistry we have a lot of high-dimensional problems.
True.
I cannot see a 4D object, but we have a lot of 4D problems.
Yeah.
Yeah, I'm a guy working on high entropy material, so the lowest dimension for me is 4D. Yeah.
High entropy materials. Let's dive into that. If you guys have questions, throw them in chat. But we're going to dive into high entropy materials. What does that mean?
Yeah, good question. Like, actually, Hadi recently told me that the polymer field already have high entropy for a long time. He actually lent me a book on that. But for us, it's like a lot of crystals, they are disordered.
Oh, now you got to fight yourself.
Oh,
it's a metaphor.
Yeah,
it's like Bruce Lee Enter the Dragon stuff right here.
Gotcha. Oh, a stronger version of myself.
Not mediocre gameplay.
Oh yeah.
It is materials that don't have a set bedtime. All right, so entropy in general, how would you define that for the Gen Chem audience?
Good question. So entropy, I think, is a measurement of how disordered the material is. But of course, there are many types of disorder. So for high entropy materials, we are referring to the disorder that in a crystalline site, you can have a probability of see different species. And then we call that mixing entropy. So, and of course, the more types of species you have, the higher entropy you're going to have, because you have more possibilities, right? So the high entropy materials is essentially when you have at least 4 to 5 elements with almost the same probability of showing up in a crystalline site. Okay, so the cool thing for them is like they're very diverse. Okay, so you can really achieve a lot of coordination environment because of that. Think about silicon, you only have silicon bond. But think about that, you mix silicon with germanium, with tin, with carbon, you're gonna have at least a choice out of 4, right? So 32 types of possibilities. And then you can play with different species. You have 118 elements or even more than that in periodic table. So that gives us a lot of chemical bonding environment. So my hope is that the diversity gonna give us more tunable space for properties that we care. So that's basically my philosophy for high entropy materials.
What's intriguing about that, when you look at the semiconductor industry for the last 70 years in terms of solar cells and like transistors, we have been trying to make better and better crystalline materials, grow better crystals. And it turns out with battery materials, crystalline might not be the way to go. Entropy helps you.
Our high entropy is still crystalline. Yeah. So it's basically mixing entropy, right? So we still have a crystalline structure. Yeah, so but in battery field there are indeed some glassy battery materials.
That's it.
Oh, that's it?
Yep, you beat it.
Oh, I see. Oh.
Congratulations.
Yeah, thank you.
GG's, we grinded it out.
GG.
It took us an hour and 20 minutes, but we beat Double Dragon 2.
With teamwork.
Thank you all for sitting through that disaster of gameplay. We did our best, but we got through it. All right, you ready for some Contra?
Oh, yeah, definitely.
Time for...
Yeah,
this one's way more forgiving. So what did you play more, Double Dragon or Contra?
Definitely Contra, but when I was a kid, I think Double Dragon seems to be more interesting. Maybe I got a guy who carried me all the time with.
Contra's this is one of the all-time classics. If you guys aren't familiar, this is one of the greats. We should look up what the speedrun time. What do you think the fastest time somebody beat Double Dragon 2 in?
I guess 20 minutes.
Let's take a look.
Sure.
So it took us an hour and 20 with Infinite Lives. Double Dragon 2. All right, speed run world record for Double Dragon 2 one player is 10 minutes and 3 seconds.
Oh, wow.
That is flying.
Yeah, exactly.
Heart lukewarm. It's not Wednesday, it's Kensday. I don't know what that means, but thank you for joining us, Heart lukewarm. Thank you for the first time chat. If you're not following us, click the follow button. It is time to follow and get notifications about future streams, future guests. Yeah, let's look up Contra. What is the Contra speedrun? What's your guess on this game? Fastest time?
50 minutes?
9 minutes and 47 seconds.
Shoot.
And that was set 9 months ago, actually.
Oh, I see. I guess probably there are more people playing Contra.
Yeah, than Double Dragon. This one's much more popular.
Yeah.
As far as I know, this one's pretty optimized, actually.
I see. Less jumpy.
It's not Wednesday, it's Kensday. Where does that come from?
I like the name, Kensday.
Oh, classic. The NES Mario record recently dropped? No, it didn't. And Mario 1? Super Mario 1? Mario 64 did. That's I know that one for sure.
What is that record? How long?
For which one? Original Mario or Mario 64?
Maybe both, like just curious.
All right, so original Mario, it's 4 minutes and 54 seconds, as far as I remember. Super Mario Brothers, any percent speedrun, the record is 4 minutes and 54 seconds.
Wow.
And as far as I know, this is within like 0.6 of a second of the computer simulated speedrun.
I see.
Or something like that. Mario 64, did you play that one at all?
I'm not so sure. Like, do you have like a scene? Like...
That's the 3D Mario?
Oh, no, not really.
Okay.
I saw that in your channel though. Like, I think someone played that before. Right?
Yeah. Emily Stewart was playing that one, actually.
Gotcha.
Contra, thank you for the sub. You don't have to sub the stream. We appreciate it. If you guys are going to sub, make sure to use your free Amazon Prime subscription for the stream. It helps pay for alcohol for the stream. It helps our drinking problem. But thank you for, and enjoy your emotes.
Contra.
Use them liberally. I do not use our emotes enough, but we got a bunch of them. A little bit of Carl Sagan plus some OSHA. Use them as you see fit. You finally got a job. Congratulations. It's good to be making money. Good to be successful.
Oh, yeah.
Spend it on streamers. Yeah, I have a few classics. Do you watch Twitch at all? Have you watched outside of this?
Not really actually. Like, but I guess I'm gonna start that. This is my second time.
You don't have to by any means, but it is a fun, like, if you find the audience, if you find the group, you find a subject matter or game you like. I mean,
I used to watch something similar.
Yeah.
Like,
On what streaming platform?
There's some Chinese streaming platform actually.
Which one was?
I don't actually know the English name.
Oh, that's fair.
Yeah, but it's typically like some mobile games and like people playing that.
Yeah.
Yeah.
I mean, if it's a game you're into, it's fun to watch good people or smart people play them.
Yeah, exactly. Time killer.
Yeah, the reason I got into Twitch at all was actually Mario Maker 2. I don't know if you're familiar with Mario Maker. It was actually Mario Maker 1 at the time. But Mario Maker is a game for the Switch where you can create Mario levels, and anyone can do it. And so you can play essentially an infinite number of levels in Mario. And like I watch people like the Beast and Grand Pooh Bear and Barb, all these people. It's like, oh, that's fun. And then I started thinking, well, we should present some science while video gaming.
Yeah, it's a cool idea.
Yeah, there's definitely a decent science communication. There's a lot of people that program on stream, actually. They'll show their programming. Gotcha. Eugene's done it a couple times, too, which is fun.
Oh, yeah. I saw his Twitter on that. Yeah. I also tried that library. I mean, that's amazing.
Yeah. That's really fun.
Yeah. Python is really cool. Like, when I was an undergraduate student, Python is not that popular. Everyone used MATLAB at that time.
Well, what's your favorite programming language?
Definitely Python right now.
Python?
Yeah. I mean, but like 10 years ago, I used MATLAB a lot. It used to be MATLAB. Yeah, so I think Oliver still use MATLAB.
Yep. Yeah.
Because he thinks Python is so weird. You have to import everything. I have the same feeling when I switch to Python, but
there's so many libraries available, right?
Exactly. You can do literally everything.
Any tool you need, somebody already did it.
Exactly. It's free.
Yeah. But I mean, that transition, I mean, talking to like Sachin, I don't know if you know Sachin Shanbag from Scientific Computing. But,
I see.
But he said that's I mean, it's a relatively recent transition, the last 10 years or so.
Exactly.
So it's anyone that started independently before then might be more hesitant to adopt it for sure.
Yeah, I totally believe Python become the most popular programming languages. Previously, it should be Java for quite a while. Yeah, and then, I don't know, maybe Visual Basic.
Yeah.
Yeah, I don't know.
That's interesting.
Yeah, and also Python becomes I think the language that can most easily get you a job nowadays.
Yeah, that makes sense.
Yeah.
So many memories watching you play this. That's awesome, Contra. Yeah, this is the classic. And this is one of those. If you knew your Konami code, you could beat this with the 29 lives and like 9 continues or whatever it is.
Oh, yeah. I think we call it like 30 lives. Yeah, there's a version with 30 lives.
Misadventures. I sometimes think about writing stuff in something other than Python, but there's so much already available.
Yeah.
I mean, it's building on the shoulder of giants, right? It's just more efficient.
Yeah, it's like a GRU language. So basically, whatever thing you want to do, hopefully there is already a library.
That's fair. All right, we haven't done any predictions. We got to do some. Let's do, how about that one? The cost.
Oh, sure, yeah.
A lot of stuff available for machine learning too.
Yeah, I do this kind of a computation every time because I have to spend my money.
So do you have like a GitHub library or somewhere you deposit all your stuff, your coding? And
we have we have a lot of private repo, but we have public repo as well. Yeah. Why do you ask that?
I'm just curious
I see.
you have a means of sharing it. I mean,
yeah, definitely. My website is also in GitHub. Yeah.
Oh, that's fine.
Yeah, my group website.
I like writing boilerplate though.
Oh, what is it?
Boilerplate. I like writing boilerplate though.
Oh, I see.
All right, we're going to put up a prediction right now. We haven't done any yet tonight because we've just been talking and chatting the entire time, but this is a fun one. Those of you not familiar with the stream, if you're not following us, click the follow button. You'll get notifications about future streams, but you'll also get 300 standard internet units that let you do things like force us to drink, as well as buy a factoid, unlock an emote, so on and so forth. But we also use the prediction function on this, so you can gamble your standard internet units on a science-related question. So I make every one of my guests, I give them a list of homework. It's a non-trivial list. It's several lengthy emails where they have to come up with a bunch of crap for me. And one of those is to come up with predictions for the stream. And so we're going to put up a prediction right now. You guys can answer this with whatever expertise you may have on hand, but no cheating, no Googling the answer, no chat GTPing the answer. Answer this question based on what you know about the universe. And the question is, what is the most expensive GPU for scientific computing? So if you want to buy the Cadillac of graphic processing units for scientific computing, how much does that card cost? Is it greater than $30,000 or less than $30,000? Which is intriguing because that's
typically people think the computation is cheaper than Fermi, but not anymore.
Depends if your GPU card is greater than 30,000 or less than 30,000.
Yeah.
The answer is going to be ridiculous either way. I'll give you a hint. It's not $5,000. But the question is, what is the most expensive GPU for scientific computing? So Ben, if you wanted to buy this right now, you could go online and find a card.
Oh, yeah.
And spend as much as you would on a used car.
Yeah, that's interesting. Like we simulate how furnace works, but the simulator we use is more expensive than furnace.
It also generates a lot more carbon. So yeah, contributing to global warming. Oh man. So yeah, the question is it greater than 30,000 or less than 30,000? I love that in real time I can see you guys changing the dollar amount of your contribution here. So depending on the degree of confidence. This is way easier jumping than Double Dragon 2.
Exactly.
Holy cow.
Yeah, definitely.
That game.
I guess that's why it become more popular.
Yeah, I'd argue it's more fun. Like Double Dragon is pretty clunky and hard. Like platforms are messy.
Yeah, it's more hardcore, I guess.
Yeah. It's fun nonetheless. All right, you guys have about 15 seconds. Most expensive GPU for scientific computing. Is this the most expensive GPU period, or is it for specifically scientific computing?
It's just any type of GPU, like.
Okay, so this is most expensive GPU period.
Yeah. For game GPU, I think most of the people know it.
All right, Ben, what's the answer?
Yeah, it's definitely more expensive than 30K.
Definitely more, so much greater than 30,000.
I'm not so sure about whether it's much greater because there's a supply chain issue recently. Yeah, so the recommended price is always lower than the real price.
Yeah.
You have to wait. Yeah, but definitely you can find something.
Jump up. There you go.
Oh, I see. Gotcha.
Then you get another boss.
Oh, gotcha. Yeah, so that's what when I had an on-site interview, like I discussed with Mike Chachat on this.
He was asking what did you need in terms of hardware. And...
yeah, I said it's like could be like 50K. He said, "Oh man, it's like a furnace." Yeah.
That's a nice furnace.
Oh,
My furnace is only 12K.
Oh yeah. I mean, I think I heard there are cheap ones which is like a few $1,000s, right? Yeah.
That's crazy though. That $30,000 for a card, and you need. I mean, what's the limitation then? You have to run that on a good board plus RAM plus memory.
And
like
also you need a good air conditioning in your computer, like liquid cooling, hopefully.
So if I wanted to build a PC from scratch with a greater than $300,000 or $30,000 GPU,
if you
what
buy
would be the total cost?
Yeah, if it's the best GPU, I think it easily goes to like $100,000 because you need a good CPU as well, right?
Yeah.
And then you need a cooling system. Yeah.
Jeez.
And also you need enough power.
Yeah.
Yeah, one knowledge is like CSL does not support that.
You want to shoot him in the mouth there.
Oh, I see. I think not all the building FSU support that. Yeah, so RCC definitely do not support that. I think waste building like support it, but CSL does not support it.
Huh.
Yeah, because you need enough power for the cooling stuff.
Wow.
Yeah.
Jeez.
Yeah, also ChatGPT, I think the training of ChatGPT cost, I don't remember, like, I think per day is like $500,000 or something like that, US dollars.
Jeez.
Yeah, for the cooling, for the electricity and stuff like that.
Yeah. That is breathtaking. So congratulations to you that said over 30,000 per card. That is crazy. I can't imagine dropping that on a PC.
Oh, yeah. And you're gonna need students to maintain it.
Exactly.
That's a problem.
Well, that's what I love about this question is because our graduate student salary at Florida State University right now just crossed 30,000. So this GPU is more expensive than a year of a student salary.
Yeah.
So
that's the calculation I'm doing every day. You know, like maybe I can pay my student instead of buying this card.
Well, that's something I did early on with my students. It was like, yeah, you broke that piece of glassware. That is 1/10 of a graduate student annual salary.
Oh yeah.
And it's math you have to deal with for sure.
Yep.
Especially postdocs. Expensive.
Oh yeah. Oh, I just see the email like postdoc salary increase.
Yeah. So what is it now? It's 54,000.
58.
58 starting in the fall.
I heard it's from next January.
Okay.
Yeah. Yeah, but I hear it's very likely, but still undecided. I haven't read that email very carefully. Yeah.
Ask the aerospace guys about simulations. Oh, that's intriguing.
Yeah.
It's like classical mechanics type simulations. I don't know aerospace simulations.
Aerospace simulations?
Yeah.
Not so sure.
If astrophysicist on, but not a aerospace engineer on. So that's an intriguing space to occupy.
Oh yeah.
$300,000 GPU. You could play so many video games on that.
Oh yeah.
Contra would look beautiful.
Yeah, actually 4090 is very cost efficient.
Yeah.
Because I think there are two types of graphic card, right? So professional graphic.
So I think you gotta go press down to shoot these ones.
Oh, I see.
Yeah, because they're down height. Sorry.
Gotcha.
So yeah, press down.
I see. I think the professional equivalency of 4090, 4090 I think now is like $4,000 or $3,000. The professional equivalent I think is double the price, but the performance is kind of the same.
That's crazy.
Yeah, so this is really very cost efficient graphic card. Yeah.
All right. What other standard questions I got to sneak in? We're at 9:38. I'm guessing Bin's going to take, well, how long do you think you're going to take to beat NARC? So our fastest time is 17 minutes. Our slowest time is 38 minutes.
Oh, really?
Yeah. Where do you think you are on that spectrum?
I always aim at the last.
I doubt that. It's easier than Double Dragon, I would argue.
Oh, I see. I'm not sure where am I right now. It's like
Press down.
oh yeah. Am I on the
Hold down. Hold down.
Gotcha.
There you go.
Gotcha.
Yeah, you'll blow those up one at a time.
Gotcha.
Move over a little bit. There you go. You hear that sound?
Oh, gotcha.
Yeah, that means you're hitting them. Yep, there we go.
Gotcha.
Millions in to compute for a spacecraft. No, I believe it. That is an expensive mistake if you don't have your models correct on a spacecraft.
Yeah.
Which is pretty intense. All right, going back to our standard questions, one of our favorites. I've watched a lot of movies, so I have strong opinions about movies and movies physics and movie science, because you see some scenes that are like, that makes sense, and some scenes that are like, what, why does that exist? So
Yeah.
can you think of a movie or TV show that gets your discipline right and what gets it wrong? And so this could be loosely defined in terms of programming, machine learning, AI versus batteries. What is,
Yeah,
what's your answer for that one?
yeah, actually I'm not so sure about that. I haven't watched that many like sci-fi recently. Like
Yeah. Watch Oppenheimer?
I didn't get a chance for that actually. Yeah, I started on a weekend.
Yeah.
And then after like 20 minutes, my baby is crying.
Yeah, it's worth mentioning.
Yeah, I was like, okay, maybe next time.
Ben has, man, what is 6 months old? How old? 9 months?
Yeah, 9 months old.
9 months old?
Yeah.
How's parenthood going?
My parents took care of him like most of the time, so.
Yeah. Are they still around, or they're gone?
Yeah. I think hopefully they're gonna stay until the end of this year.
Okay. Yeah.
Yeah, but at night typically I'm on duty.
Yeah. That's brutal.
Yeah, I'm technically on duty, but it's mostly my wife, because I realize she's much better than me on that. Yes. But still, sometimes I have to be responsible for things.
Yeah. And it's exhausting. I get it.
Yeah, it's a lot of fun.
Especially the first year is really a battle.
Yeah, exactly.
But 9 months, you're starting to get a consistent sleep schedule?
Oh, even actually on the third month.
Oh, wow.
Yeah.
That's amazing.
Yeah. Our little baby never wake up after like 11 p.m.
Wow. That is glorious.
Since Christmas. Christmas is like his third month.
Yeah. That's amazing.
Yeah, that's amazing.
So then starting in January, you guys are going to do daycare then?
We are waiting for that. I mean, daycare is kind of a popular everywhere.
Hey, isn't it hard? There's like wait lists and you have to
I'm
visit a
waiting
bunch
FSU daycare for like a year already.
That's crazy.
Yeah. And another one for like 3 months.
Yeah.
Yeah, I hope it's to get it before. I heard like 1 year is a huge gap, right? So,
yeah. What blows my mind is you have to plan daycare 1 year out. So basically, immediately when you know you're pregnant, you have to find a daycare and reserve it.
That's exactly what I did. I'm still waiting.
Yeah. All right. So you've gotten some sleep at least, but not a lot of movies. That's the answer. So there's nothing you remember? Anything classic? Science movies, sci-fi?
Yeah, one thing like I'm trying to do is like the VR thing. Yeah, I realize a lot of VR thing is actually happening right now.
Mm-hmm.
So that's cool. Have you tried like the most recent like the Apple Glass stuff?
No, I haven't tried any.
Oh, that's amazing. Like, I tried it out.
Yeah.
The only problem is like if you wear it for a long time, it doesn't feel comfortable.
Yeah. It'd take a while to get used to, I imagine.
Yeah, exactly. Otherwise, I think it's almost close to what I saw in the movies.
Wow.
Like 10 years ago.
Huh.
Yeah, so...
That's fun. So your students had that, or when did you get to try it?
I just tried it randomly in the Apple Store.
Oh, okay.
Yeah. And it's kind of funny, like they have a special person taking care of that, and they're gonna introduce all the features and for half an hour. It's like a watch some kind of
How much is it for Apple Glass?
I think it's $4,000 for the cheapest version, if I remember.
4,000.
Yeah, $3,000 to $4,000.
So one of my former undergrads, or one of my former grad students, my first grad student, he actually went to work for Kodak, and he was back in town last week doing measurements on our STM. But he has it. He says he really likes it. Like he sits there and watches movies and stuff.
Yeah, exactly.
Like you control the interface and
yeah.
Have you tried the high-end headsets?
I'm not sure what is the big differences. I think
you got to jump on this one. Jump shoot.
How do I do jump shoot?
So jump in the air, whatever the jump button is. I don't remember which one it is.
I think up is to jump, but I see. Gotcha.
Yeah, so get in the center and then you'll have to jump shoot.
Gotcha.
The Viharo XR4.
Oh, not so sure about that. Yeah, I should probably.
And is this getting to the point where it's worthwhile? Mixed reality headset for professionals.
Wow.
The Viharo XR-4.
Yeah, it looks heavy though. Like, yeah, I think the biggest challenge is $6,000.
$6,000.
No wonder.
Oh, so this is it has cameras out front. So this is an augmented reality. Wow.
Yeah, I think the Apple one have the same.
Oh wow. Okay, so that was the cheap one.
Oh wow, there's a $10,000.
Wow, that is incredible. You guys should take a look at this website.
Yeah, definitely.
It literally has tiny fans to keep your face from sweating. It's amazing. Misadventures, I hope you own this. Tell me you own this. I want to know how good this is. That is amazing.
I'm not sure how it feels if I play Contra.
I mean, so your option is to get a high-end GPU or to get 3 of these things.
Oh yeah, for sure. Yeah.
Oh man, that is intriguing. I mean, do you think your students could be more productive with something like this? Is it better control?
Oh, we're actually trying to do that. Like, we want to bring this to teaching.
Oh wow.
Yeah. So especially when you're demonstrating like molecule that is complex or crystal structure.
So you can see it in 3D space.
Yeah, you just need a cell phone, like a Pokemon for chemistry, basically. Yeah. So you can scan anything, scan your table, like maybe the crystal structure or the molecule formula, some atomic structure gonna show up. I think it makes more sense like when students can directly interact with something they learn.
Yeah,
that's
fun.
Yeah. So it's not so hard nowadays, and again, thanks to Python and all those kind of libraries available, you don't have to reinvent the cars.
Oh, so that's fun.
Yeah, that's a cool thing.
So Misadventures doesn't own one of these, but they got to play with it in a lab that's looking at a space station.
Oh,
so
wow.
like, man, that is pretty fun.
Oh yeah. I think the Apple version have the same thing. That really impressed me.
Eventually, I'll get it. Probably when my daughters are old enough to like get into the gaming aspect of this, I'll start getting the like headsets and augmented reality.
Gotcha.
For now, I'm playing Contra and Double Dragon. I look forward to them learning how to program this.
Yeah.
So yeah, shoot those red guys, the red circles.
Gotcha.
You need to blow up, I think, all 3 of those.
Oh, I see. Gotcha. I'm gonna focus one.
Man, the XR4 Focal Edition is $9,999, excluding tax. So you're paying over 10 grand for one of these.
Oh yeah.
Augmented reality, but I bet it's beautiful. It's absolutely amazing, I'm sure.
For sure.
It better be for that price. It better give you fans on your head and back massages. Thank you, Misadventures. That's incredible.
The only negative comment I heard about is like you're gonna feel exhausted by welding this for a long time.
Interesting.
Yeah.
I mean, so you have to move your head to like control certain things.
Yeah, and it's a little bit heavy. Yeah, that's the only bad and downside of it.
I mean, and that's I've heard that with many technological innovations. Like when people were arguing touch screens are going to take over everything, but touch screens are exhausting. You have to move your arms a lot. You have to move your hands a lot. When a mouse, you need to do like 3 inches of space, and you control everything.
Exactly. Yeah, and moving fingers takes more energy, right? So because you need more precision. So.
But the neat use case, besides the obvious stuff, is you can put someone in an environment, give them instructions, and watch where people's eyes are looking for an ergonomic view / safety design. Oh, that's intriguing. So you can actually simulate the space and see how people respond. It's like a real in situ study. That's really cool. Huh.
Yeah, exactly. I think this kind of extended reality coupled with AI, you can really simulate anything in real life.
Yeah.
Yeah, I think one thing I'm really, I'm really impressed is like they have those kind of a demo video to show how fancy this can be. It's like you really feel that you are in a concert.
Yeah.
Yeah, so I mean, it's basically a combination of multiple things existing, like a good like headphone, for instance, and also you're gonna see the depths of the video in front of you, and also like you can see also the real person in front of you telling you everything behind this thing.
Yeah.
Which is really interesting.
But if we're being honest, most people are going to just pretend a roller coaster, right? That's what they're going to do.
Yeah. That's typical VR thing. Yeah.
Wow. Yeah, you can export eye movement and heat beat into a CSV. That I love that stuff.
Wow.
Or heartbeat. Sorry, heartbeat. I was thinking a heat map, but tracking eye movements and heartbeats while somebody functions, particularly on a space station simulation, is intriguing.
Oh yeah. Yeah, also the Apple Glass, they can track your eye movement. You literally use your eye to control that, which is, I mean, in the very beginning, I don't believe it.
Yeah.
Yeah.
No, I've seen a lot of that in like chemical education. Like when you think about how an expert versus a novice thinks about like a chemical reaction, when somebody that's an expert sees a molecule, they key up on very particular aspects of that molecule, and you can actually see it in these eye tracking softwares.
Very interesting.
Yeah, they just know what to look for, right? What does it mean to be nucleophilic, electrophilic? They see it right away.
Sure. Yeah.
So that's definitely intriguing.
Gotcha.
So you got to hit this guy when he's together.
Yeah.
It's the only time you can shoot him.
I see. Gotcha.
Man, that's really cool, Misadventures. That's a really fun applied. Man, I'm a bit jealous. I need to try one of these $10,000 augmented reality headlets. That is amazing. All right, we're at 9:50. We should do another prediction. Which one should we do? GPU hours? We do that one?
Sure, yeah.
Just move up the chain. All right, we're going to do another prediction. If you're not following, click the follow, so on and so forth. I'm not going to repeat all that again because I already did it once tonight. But yeah, click the follow button, get your standard internet units. We're going to put up a prediction right now. You're going to have 2 minutes to answer this question. So Bin's research group, he does computational chemistry. They use GPUs to do some of those calculations. So the question is, how many GPU hours per year does Bin's research group do? So you have what? Between grads and postdocs, you probably have 8 students. How many do you have? Or 8 people in the group?
I think it's 5. But if you include, we have some master students on the data science program. If you include them, we have 8.
Okay.
Yeah.
So eight people running GPU calculations in bin groups. How many GPU hours do they use? That's 1 GPU running for 1 hour counts as 1 GPU hour. So the question is, how many GPU hours does Bin's group use in any given year? We talked about a $30,000 GPU. If you had that.
Yeah, except that we don't buy them.
Yeah, exactly. If you did, would you do more GPU calculation?
Yeah, the thing is like when you write a proposal, like a theory-orientated proposal, you can get GPU hours for National Lab as well. And also we can buy GPU hours sometimes without maintaining the GPU, because maintaining GPU actually costs more than just buying it. So that's the problem. And also you need your student to have that expertise.
So Misadventures, what is his budget? So are you limited by budget, or do you just calculate as much as you can?
Definitely limited by budget. Yeah, if you buy GPU hour from a company, it's actually I would not say that expensive, but it's actually not cheap at all. It's like 50 cents per GPU hour. Basically.
That adds up quick.
Yeah.
Cuddle Puppy's asking the important question: why are those trees throwing grenades?
Good question.
just keep going.
Oh, I see.
Keep going. Yeah, you're
Good
going to get
question.
blown up occasionally. Just keep going.
Gotcha.
This is speedrun strat. Why are trees throwing grenades, Cuddle Puppy? Cuddle Puppy, welcome back. It's always a pleasure
Yeah,
to have
maybe
you.
someone hiding behind it. Yes.
All right. So, Ben, in terms of GPU usage, greater than 100 million GPU hours or less than 100 million? What's your answer?
It doesn't last because our hope is to go beyond that, but unfortunately not for now because you can do the calculation, right? So if we can do 100 million, like each one GPU is like 50 cents nowadays, then technically I'm super rich now.
Nice. So what's your number if you had to guess in terms of GPU hours?
We can actually get very close to like depends on how hard we are working typically. Yeah, but I think like 1 million 10 million can be very easy. Like 100 million not so much for now. Yeah.
And so what's that limited by? I mean, you're preparing a job to submit, you're programming something that you want to look at, you submit that. What does an average job cost in terms of CPU, GPU hours?
Yeah, it's not limited by the science actually. It's actually so most of our GPU actually coming from some public resources. So in this case, I think it really depends on how organized you are. Yeah, so how organized you are meaning that you know what you are doing actually because there is a queuing system. Yeah, and you need to have good idea to get allocation. That's the beginning point.
I see.
And then everyone is sharing that resources. You know, we are not. Well, I'm a cheap man, so I don't buy it myself. It's too expensive for me. Then in that case, you have to plan ahead of time. Yeah, don't wait for the last day of the year to do the computations. So that can give you some allocation, and also you have to optimize your workflow because otherwise you're gonna waste a lot of resources. All your code gonna wait for 10 days and gonna run just for 1 second, and a bug shows up, you have to go back and debug it. Yeah, so it's all more about how organized you are and how efficient you are and how well you prepare for it.
So you're uniquely positioned. I'm curious. You don't have to answer this question. I'm just doing a thought experiment right now. Is that you can presumably track your grad student and postdocs' usage of GPU and CPU times. Is there a correlation between, computational time and productivity and papers, and is there any relationship there?
Yeah, that's a very good question. So yeah, first of all, we can definitely check because we can technically see how many CPU hours and GPU hours each student have run through. I haven't really checked if there's any direct correlation.
I mean, you need a pretty big data set. You need several grad students, obviously.
Yeah, and another important thing is like how do we quantify scientific output? Typically, we use like number of papers, for instance. And I think that's the most frequently used thing, right? So, but there is no such saying that you need how many data to publish a paper, right? Yeah. Yeah, sometimes it really depends on how cool the idea is, right? So if it's a cool idea, maybe just 10 data points can be a paper. Yeah, if it's more routine thing, then maybe you need a lot of data to be systematic. Yeah. Yeah, so in that case, I feel there is less correlation actually on that. Yeah, and the part I like is to use a small set of data actually sometimes, and to use to actually use a relatively simple equation and theory to explain complex things. I think I kind of enjoy to solve problem in that way. That's fun. Yeah, because this is when you feel like you're really smart. Yeah, because everyone knows the equation, but you're the guy who found that this can be useful for the problem. Yeah.
No, that's true. Depending on how efficient you are, the same paper can be a byproduct of 10% of the effort or CPU time. Right?
Yeah, exactly.
Wow, that's intriguing.
Yeah, saves money as well.
I mean, it would be intriguing to find an efficiency metric that you could quantify, because you would presumably see your grad students like exponentially increase their efficiency over time.
Oh yeah.
They just get better at using their time wisely. And
yeah, and another thing is like the number of CPU hours they use does not correlate with how hard they are working actually sometimes, because you have to develop code in the very beginning. Yeah, sometimes you develop a very sophisticated code, but you only run it for like 10 hours. And in other cases, for instance, you use a commercialized software, you run that for like 10,000 hours, but you don't need to do too many things on it, right?
Yeah.
So the workflow probably is existing. Yeah, so in that case, the previous version actually takes more effort, but it doesn't show up in the CPU hour usage.
That makes sense.
Yeah. I should hit this guy.
Yeah, if I remember correctly, you have to hit him in the, right there in
Gotcha.
the eyes.
Yeah.
I think you got, what, 2 levels left, maybe?
I guess so. Stage
Energy
6.
zone? I think it's stage 8 or 9.
I see.
Oh, yeah. I watched the occasional speed run of this game. 10 minutes. That's all it takes him. Oh, all right. If you guys have questions for Ben Ouyang, he's happy to answer them. He's an expert in computational chemistry and particularly using large data sets, whether it's data mining or using machine learning or, just trying to use machine learning and AI to try to figure out new structures and things like that, particularly for energy storage and energy conversion materials, battery materials. If you guys have questions for Ben, he's happy to answer them while he's marching through NARC. He already beat Double Dragon 2, so now you're going to get through NARC.
Yeah. Second game.
Yeah. Well, we'll take these victories, even if we're cheating. It still counts as a win, ladies and gentlemen. But if you have questions for Ben, he's happy to answer them. Oh, Powcat, thank you for the follow. I completely missed that. I apologize 8 minutes ago. Hopefully you're still here in the stream. So thank you for joining us. Thank you for the follow. If you have questions for Ben, throw them in chat. No matter how crazy those questions might be, we are happy to talk about them while we play a little bit of Contra. So how long has it been since you played some Contra?
Oh, it's still like at least 15 years, I guess.
Mm-hmm.
Yeah, when I was a college student, I played with these simulators before. Yeah, for a little bit.
And so you mentioned a few different, like the open world multiplayer games. What's your go-to since playing NES, things like that?
Oh, what is that again?
In terms of video games.
Oh, you mean the open world game? Yeah. I actually get lost in those kind of games. Yeah, because it's so open. So, yeah, I feel like Minecraft, for instance, play that a little bit.
Mm-hmm.
I enjoy more watching other people playing it. Mm-hmm. Actually, I think someone built a computer.
Oh, in Minecraft?
Starting from,
That's crazy, isn't it?
from transistors, right?
Yeah.
That's amazing. Yeah, so I enjoy more watching other people playing it because I imagine that I gonna spend maybe 10,000 hours. Maybe that's too much, 1,000 hours playing that.
Yeah.
Just too much for me.
Well, I've spent more hours playing some of these video games than I like to mention. Especially NARC. It's embarrassingly long how much I played that game.
I see, gotcha.
Right. Misadventures, I have a practical question. Where is my solid state battery? How close are we? Right now, batteries use ethylene glycol or something for their
it's
liquid electrolyte?
It's actually commercialized already.
Mm.
Yeah, we talk about a company called QuantumScape. I think Bill Gates is the major shareholder, and Volkswagen also owns a lot of shares of that company.
Mm.
It went public offering in 2020.
But you can buy a solid state battery.
That's the interesting part. They claim so, but not all people believe it.
So if I go on a website right now, I probably can't find it.
Yeah, if you go to website of QuantumScape, what you're gonna see is definitely solid state battery. It's commercialized. Yeah, they have customers, but the problem is some people have the concern that this is not real or solid state.
Oh, interesting. So they're still using a solution, something or other.
And also, you still have some liquid in it.
I see.
So that's the problem. It depends on how many liquid you have.
The amount. When do you get to call it solid state? It doesn't have to be pure solid state. Solid state enough.
Technically, it should have zero liquid.
Huh.
Yeah, but the trick people are playing nowadays is they add a little bit of liquid to make things better. And also, liquid does amazing things here. Even if you add a little bit of liquid, the battery will look very different or behave very different. So, but I don't know. I don't know what happened. I'm not in that company. But
how optimistic are you? We're gonna have solid state batteries sometime in the near future.
Yeah, I think it's close actually. It's definitely close. Yeah, the only concern is the cost right now. Yeah.
That's fair.
Yeah.
Mr. Raindrop Woohoo Fun Time. Thank you for joining us on the stream. The question is, has anyone read Linus Pauling's The Structure of the Chemical Bond? I have not. That's one of those classic chemical literature. Like Linus Pauling was one of the early popular educators.
Pauling's rules, I use that a lot.
Yeah.
I feel like it's really useful even nowadays. Like it's very simple rules. I don't remember how many Pauling's rules it has.
Structure of the Chemical Bond.
Yeah. I probably have that book, but I'm not so sure if I read it completely.
The nature of the chemical bond? Pauling was one of those. We don't have a lot of popularizers in chemistry, but Linus Pauling was one of the few.
Oh, yeah.
Right? Like he was one of the icons.
That's
So, Mr. Ray and I apologize. We haven't read it. I'm familiar with it. I just have never actually read the original. It's kind of like reading a Gen Chem textbook at this point.
Oh, yeah.
I don't know if I want to dive through that guy.
Maybe I should jump, I guess. Oh, I see.
Yeah, and then duck when you get to the next platform. Yep.
Oh.
My favorite site doesn't appear to have it. Site in quotation, so some sort of sharing site of some kind. We won't talk about what it is. I would be impressed if anyone read the classic text. It's one of those you feel like you should read it, but then when you sit down, it's like, do I really want to do it?
Yeah.
No, that's a fun question, though. I respect the classics. I don't necessarily want to read them, though. All right, we just crossed 10 o'clock. Anyone just joining us, Ask Scientist Gaming, mediocre gameplay expert science. Our expert today is Ben Ouyang, who's an expert in computational chemistry, processing big data sets to try to discover new materials for battery or catalysis applications. While we struggle through a little bit of Contra, we beat Double Dragon 2 earlier tonight, which is pretty exciting. A lot of jumping hard parts. But if you guys have questions, feel free to throw them in chat. Yeah, if not, I have a couple canned questions that we'd like to ask regularly. We asked about movies. There weren't a lot of good examples, mostly because we haven't watched movies lately. But also, the other one we like to ask is unlimited budget, no moral qualms. What would you do? What would you run? Would you generate a $30,000 GPU processing multi-core, or how would you handle that?
Yeah, I was actually asked that during one of my interview for faculty position. It's almost the same question. I think the original question is like, if I give you unlimited funding,
what would you do?
Yeah, what would you do?
Was that a one-on-one meeting or in front of all the faculty?
It's in front of the committee at least.
Wow.
Yeah, I don't remember how many people. I think it's like 4 people, I guess, at least.
Huh.
Yeah, 4 to 5. Yeah. So at that time, my answer was like, because I was working on high entropy battery materials, like this is kind of my personal signature. So I'm saying like I'm gonna start a company trying to commercialize the things I'm developing. Yeah, but the people who interview me have no knowledge about battery. Yeah, he's doing bio stuff.
I see.
Yeah, he's kind of confused why I need to keep working on battery if I have infinite money. Yeah, so that's the part which I still, because I'm keep thinking that whether I impress the people who interview me or not, but think not.
I mean, infinite money solves your problem, but not everyone else's. Like, what the hell kind of question is that?
Yeah.
What kind of lens is that? Like, I can make the world better if I have money.
So, yeah, I guess...
Related to that comment, before we move on to the actual answer, is there was a tweet recently, it was like, there are people that have billions of dollars right now, and what they use that money to do is make more money. It's like, you could solve a lot of problems. You could right now.
Yeah,
it's like, you're literally a bad guy if you don't do that.
Yeah, exactly.
And that's the issue. So anyway, sorry, what's your real answer?
I mean, I'm kind of stick to the same answer as well. Like, I mean, for me, I think clean energy is a big enough problem. But the cool thing is like I can have more freedom on doing whatever I want to do. I don't need to struggle for looking for money.
Which
I
we
don't
spend
have.
most of our time doing as professors.
Exactly. I don't need to think too much about how much money I have left to pay my students, and I can buy whatever GPU I like.
Yeah.
I can train whatever machine learning I would like to do.
Yeah.
Yeah. So in that case, I think it will be cool. Like maybe I can build some for my version of Jarvis for battery. I mean that would be nice. Yeah. So. Yeah.
And that's generating a tool that anyone could use, not just you. So that would be useful.
Exactly.
All right, I'm going to let you focus on this part. You have to be patient, duck, because it's a consistent pattern. Right? 1, 2, 3.
Oh,
1, 2, 3. Contra, use it to discover ducking. Duck. Just press down. Go a little bit. Press down.
Oh, I see.
Go a little bit. Press down. Patient. Down.
And then I jump again?
Yep. Jump and press down. Press down.
Oh, nice.
Oh, jump, press down, jump. So you can't press down and A because it'll drop you through the floor. So you got to let go down.
Gotcha.
Contra, thank you for not being the only one. Ben was like driving me crazy momentarily. We'll call that a rage emote.
Oh, I see.
Duck. Stand up and jump. Duck. Stand up and yes.
Oh yes. Thank you for the tip. I didn't realize that.
You're using. That's an excellent use of deity Carl Sagan. Thank you.
I see. Oh, that's interesting.
That's awesome. Carl, is that the command? Yeah, there you go. If you want to look up the origin of some of these emotes, Contra, we have a Nightbot command for most of them. So,
I see.
There's the DD Carl. All right, same thing on this one. Just duck.
Yeah, I realized.
You got this.
Gotcha. Oh.
So you didn't answer the question. What's your NARC timeline? What do you think? Between 17 minutes and 38 minutes, where do you think you're going to be on the NARC? How long it's going to take you to beat the game NARC?
Oh. Well, how long I spent already? Like.
No, not this one, NARC. The next one we're going to play, the drug game. I'm gonna say 25 minutes. Maybe
Really?
We start at like 10:35, something like that. 25 minutes is a reasonable timeline.
Yeah, we can give it a try. Like.
Yeah, but I think you can beat Contra before then, so let's do it.
Yep.
All right, GPU hours. That's fun. Misadventures. When are you guys going to work together and solve the energy crisis? I don't know. That's tough. Like, we haven't found a collaborative effort. Well, one, Ben's an assistant professor, so he has to kind of carve out his own thing. So collaborations are okay, but try not to lean on assistant professors too much.
Good news is like I'm going to organic side, which is what Ken is good at.
Yeah, I do much more molecular things than solid state things. So
hopefully in a couple of years.
Yeah, exactly. Let's figure out. But I'm very interested in molecules on inorganic surfaces. Oh, so this one you can't duck under. You have to like jump over. Oh, never mind. Skip it all.
Oh, wow. Didn't realize that.
We'll take that.
Okay, that works.
So I think you just get up there and duck.
Oh, no.
That's nice. It's progress, though.
Yep.
So now you have to press down and A.
Oh, gotcha.
And that'll put you through the floor, because that's the rules of Contra.
Got it.
I don't know how it works, but it does work.
Oh,
Yeah,
that works.
Go.
Oh, I see.
Man, was this easier or harder than you expected in terms of gameplay while talking?
It's actually harder there, I think.
I can definitely see it when you're like
I suddenly
on a narrative.
Yeah, I suddenly understand my wife. Yeah, because I feel she hates me more when I play game and talk with her.
Because you can't do it.
Yeah, this is because I cannot focus.
I hope she's watching or she gets to see this video. So
yeah.
Oh, that's amazing. So yeah, and this one's for you. So we'll have you on in no time. So yeah.
Yeah, I was always confused why like she hates me so much when I was playing game.
Now it all makes sense.
Oh, yeah.
That's amazing. All right, if you guys have questions for Ben, feel free to distract him so he struggles to talk and play video games at the same time. If not, I'll ask him some questions about, man, what are our other ones? What's your airplane conversation like? So you sit next to someone on an airplane. I don't know if you actually have this conversation, but if you did, and they say, what do you do? What's your answer?
Yeah, so I think previously we talked about why, it's a random question, like why Tallahassee Airport is international.
Mm-hmm.
And I think there's a high school kid, I believe he's a high school kid. He told me there's no international flight ever.
Out of Tallahassee, is that true?
I heard so. Like the only reason why it's called international is because you want to be international.
But don't they go to Puerto Rico or something, or Bahamas, or it's something southern?
I have never seen a list, but I didn't fly enough, I guess. Yeah, I have never seen at least, I fly at least like 10 times already, or 15 times. I have never seen any places, I guess.
That is interesting.
Yeah.
Huh.
And I think that high school kid told me that because he wants to be international. I think that's a cool reason.
I'm gonna look it up. It's an international airport.
Yeah, definitely. Yeah. I thought about this for a long time, actually. I was so confused. Each time I was in the airport, I was like, there's no international flight.
Yeah. Non-stop flights from Tallahassee. Charlotte, Atlanta, Raleigh, South Bend. Huh. And that might be true. I wonder if the commercial flights go international, like the delivery flights. Not necessarily the personnel flights.
Gotcha. Maybe.
I don't know. That's a good question.
I see.
All right. Mr. Raindrop. Oh, actually, we got a request to factoid from Huggy Beer. Huggy Beer, welcome back to the stream. Evening on Happy 4th for those in the U.S. Yeah, it's 4th of July tomorrow. Hang out and celebrate and listen to fireworks all night. We actually heard some tonight just outside the room here, which is kind of fun. But Ben, factoid, knowledge bomb you want to drop on the audience. What's your...
Yes, so I have some really strange knowledge I would like to share.
Let's do it. Strange knowledge is what we're in for. It's 10:14 at night. Let's do it.
Am I supposed to make the choice?
Yeah. Pick whichever one you want to talk about. Share what your factoid is.
Yeah, I got one which is really interesting. I know that recently, actually, even myself. Yeah, is there any like specific thing we need to do before we do? Oh, gotcha.
You want a drink? Are you good?
Yeah, I'm good. I can probably take another one later.
All right.
Yeah. Yeah. We're gonna talk about a fun fact about periodic table. Yeah, so a lot of elements, when they are translated into Chinese, the word does not exist. Yeah, so, and we're running out of Chinese characters for that specific element. For instance, lithium. The Chinese version of lithium does not mean anything. It only means lithium element.
It's just phonetically spelled out.
Yeah, and also baranium, for instance, it doesn't mean anything. So they are taken from the family name of, the name of the emperor in Ming Dynasty. That's a special reason on it, because that family have so many kids. Eventually, they end up to be a giant family of a 1 million population.
Jeez.
They have the same issue. They are running out of characters. So they create random characters for this. So, and then we will translate periodic table, which is about 200 years ago, into Chinese. And I don't know who think about this, he decided to take the name of those, the family from a dynasty that is already 500 years old. And so I think half of the periodic elements, they are taken from the name of that family, like lithium, baranium, and also barium, and I think pretty much everything that we see. Carbon is different. Carbon is a real word in Chinese. Helium is also, it doesn't exist. It doesn't mean anything in Chinese. And also, I mean, maybe you can come up with anything. I can tell you whether this means anything in Chinese.
So they're repurposing the symbol for the element? Is that what they were doing?
Yeah, actually, this used to be the name of the emperor family. That's the first place when people use it.
Yeah.
And then they want to use a Chinese character to translate lithium, and it should sound like lithium.
I see. Okay.
And then they just directly
It's
take the
phonetic.
name.
Yeah.
Just reuse it. Yeah, so that's really funny. Like,
Oh, man.
it doesn't mean anything. Most of the elements in Chinese.
I have a coffee cup with Chinese symbols on the periodic table. I should ask you which ones are nonsense.
Oh yeah. Most of them.
Most of them. That's awesome.
Yeah.
All right, Huggy Beer, there's your factoid. I didn't know any of that. Is there an equivalent to cheers or salute in Chinese?
Oh yeah, definitely. Like Chinese cheers is like ganbei. Yeah.
Okay, so they've requested us take a drink, so let's cheers in Chinese.
Oh yeah, definitely.
So cheers,
Ganbei.
Ben.
Yeah. Cheers.
Gambe?
Yeah.
That's what. All right. There we go. Wait, Americium is Mei from Meigao?
Not so sure. Like Meiguo is for the name of USA. It's like the country of beauty. Yeah, that's also there should be a story behind it, but actually I don't know that story. Why US is translated into the country of beauty, like France is translated into the country of law, which is a little bit strange. Yeah.
That's interesting. Curious when that evolved.
I think it's because of the pronunciation.
Oh, interesting.
Yeah, because France in Chinese sounds similar to the Chinese word raw. American, the May sounds like beauty. Yeah, the Chinese, I think it's because of the pronunciation mostly. Yeah, they just choose a positive word out of all the words with the same pronunciation.
So Matt isn't a robot or a Robert. Great, now I'm gonna have to cover up all my tattoos. So this is a running joke on the internet where like an American person will get a Chinese tattoo.
Oh yeah.
But they don't know what it is, so it could be like, you know, I don't know, beef stew or whatever, right?
Yeah, exactly. I saw very interesting ones.
But along those lines, so if somebody got a tattoo of the chemical elements, an average Chinese person wouldn't recognize those?
Yeah, definitely. They're gonna realize this is a element. I think most of Chinese people know the basic element, like lithium, for instance.
Yeah, but if you get up to like americium and curium and
yeah, they're gonna look
californium,
strange. Yeah.
so they'll just be random symbols to them as well.
They're gonna think this is your name. It's used to be someone's name, you know?
Yeah. So Matt, you're fine. Don't cover them up.
Oh, yeah.
It's a 500-year-old dynasty in China. That's what they'll assume. You're the nephew of whoever.
Oh, yeah. They just have so many people in their family. Like.
That's pretty intense. That's a fun fact. So Huggy Beer, thank you for requesting that. Hopefully you got your 2 cents worth out of that one. Or your 500 internet units, whatever it costs. I don't remember actually off the top of my head. But all right, Huggy Beer. Does the good doctor deal with grid-sized batteries? I had an uncle who used to look for places where he could use water-based batteries. Water-based batteries? I don't even know what that
There is actually water-based battery called aqueous batteries.
Oh, it's aqueous, like redox mediator solution. Kind
yeah, some kind. The electrolyte is basically some kind of a water, some maybe organic sense, but also could be inorganic sense.
Wow.
Yeah, within water.
So you can shoot these platforms and they'll blow up.
Oh, I see. Gotcha.
But if you run into them, they will kill you.
Oh, I see.
Oh, that's interesting. That the
yeah. It's actually a very popular battery nowadays.
Huh.
Yeah, because you know, it's not flammable. Liquid battery have the issue of flammable. You know, like in the very beginning, people, you know, the conventional classic, you know, car manufacturer, they want to stop people from using Tesla, so they just show those videos when you know, Tesla caught fire. Yeah, this is because a lot of organic molecules people use as electrolyte, they're flammable.
Yeah,
so,
it's a whole lot of ethylene glycol, right?
Yeah,
that's a default one.
Exactly.
And it's flammable. It's like an alcohol, basically.
Yeah.
With a slight modification.
Yeah, I had a friend who is a battery safety engineer in General Model. He told me that if you're driving electric vehicle, when you have a very serious collision, and it seems like your car will catch fire, you only have like 10 seconds to escape.
Jeez.
Yeah, otherwise the temperature gonna raise up into 1,000 degrees C in about 10 seconds.
And that battery's in the floor of your car, like it's distributed.
Yeah, it's like a chain-like reaction. So
wow.
Indeed, it's risky, but not that risky. You know, not many people have that kind of collision. You know, typically it's safe. Yeah, but that kind of a 10-second reaction time really, you know, shocked me.
Oh, Huggy Bear's talking about different batteries. The lakes you can pump uphill and then let it flow down to generate power. So the gravity-based potential energy. Yeah, very different than what we're discussing. I apologize.
Yeah.
But yeah, batteries, you basically need a way for the two different electrodes to talk to each other.
Yep.
And so you need some sort of transport medium. And so solid-state batteries use something that's solid that can move ions.
Yeah,
but you have like non-aqueous and aqueous. So non-aqueous would use things like ethylene glycol, which is common in most batteries. But apparently you can do aqueous ones as well.
Yeah, that's why people care a lot about the solid-state and aqueous ones, because, you know, it's not flammable, or less flammable, I should say.
I mean, because you have a high-pressure, flammable liquid inside an electric chamber that can arc and ignite. Like, yeah, it's intense.
Yep, exactly. Like, you don't want to drive on a bomb.
Yeah. I'm going to argue, Huggy Beer, the energy storage via gravity should not be called a battery. But maybe that's my formalism. I don't know what the IUPAC definition. Let's look it up. What does IUPAC define as a battery? Because it is energy storage, but not all energy storage is equal, right? Like nuclear is energy storage.
Hydrogen storage, for instance,
IUPAC battery definition.
I think as long as you have positive and negative electrode and some ions are moving through.
I don't know if they have an IUPAC definition of battery.
Yeah.
I tried to look up the IUPAC definition of device, and they don't have that either.
Yeah, I feel like maybe Gen Chem have.
Yeah, that's true. The Gen Chem textbook might.
It's not that complicated. I feel like as long as you have two electrodes and there are some ions moving around, it can be called as a battery. Yeah.
Yeah, I think that's, I mean, as long as it meets a galvanic cell type definition.
Yeah, exactly.
All right. Contra wants to know, all the talk about lithium and potential and then sodium made me want to relate to something I've heard a lot about lately. A series of personal experiments led me to study voltage-gated ion channels and and the genetic addresses that code for them. It turns out that mutations affect the ability for these channels to deliver different things across cell membranes. Some of this is dependent on sodium channels and how they function.
Oh, sounds like a biological problem.
Yeah. So have you looked at this at all? Sodium potassium pumps inside like muscle discharge and things like that. Are you familiar with these? I mean, that is essentially you're generating a potential. It is a battery, or at least a capacitor, maybe.
Yeah, sort of. Yeah.
Follow up on that. Long story short, it turns out that lithium has a higher affinity for sodium channels than sodium itself, and introducing small amounts of lithium can help kinds of cellular transport. I have to wonder if the properties of lithium that you mentioned earlier are behind this. Probably. I mean, it's much smaller. Like, it fits through everything.
Yep. Yeah, if it's related with affinity, I mean, it can expand a broad spectrum of things, right? So,
yeah. And the thing about lithium, I mean, that's why they use lithium drugs, right, for brain and things like that, because it disrupts channel communication, things like that.
Yep.
All right. Calcium ion channels I was looking to initially. Yeah, discharge in like neurons and stuff is really cool, because you're basically making a charge gradient along the axons, and that's how it does signal processing in neurons, which is, I mean, it's classic electrochemistry.
Gotcha.
Just momentary charge. It's just brute forcing this one. Lithium was used to treat depression and bipolar. Yeah, lithium, I think it affects the discharge of those neurons in the brain. And so you can slow down over discharge and things like schizophrenia and bipolar and all sorts of stuff. So yeah, really cool use of like small ions that can move across membranes. As far as I know. I'm not an expert in the biochemistry by any means. We did have several neurobiologists on. Actually, we're going to have a neurobiologist on in a couple weeks, actually. So that might be a question to save for them, lithium ions and neural processing. But it is fun, that biological crossover.
Yep.
So you think about biochem at all?
It's even harder.
It's true.
Yeah, I feel like the hardest thing is the nomenclature. Yeah, I definitely believe there are things in common, but I need to understand those molecules first, so that's the thing.
I've said the exact same thing. So you need to shoot that thing.
Gotcha.
That is how you beat this level. So you can kill everything, or you can just shoot that stupid thing.
Gotcha.
So I would run, yeah, just like that.
I see, got it.
Go Haku, what did I miss? Is it NARC time? You are here almost exactly in time for NARC. Go Haku, welcome back to the stream. Our guest today is Dr. Ben Ouyang. He's an expert in computational chemistry, high throughput, big data mining, using like big data sets to try to figure out of, 10,000 compounds, which one could potentially be promising as a battery material based on computational results. So yeah, if you have questions on any of these things, feel free to ask those questions. We're on the last level of Contra, and we're going to beat this level before we move on to NARC. Ben already beat Double Dragon 2. Now he's going to beat, that's the last one? Last level here, yep.
Awesome.
So yeah, progress in the right direction, for sure.
Yep.
But yeah, if you guys have questions about battery materials, about processing big data, Ben is happy to answer them. He gets heavily distracted from his gameplay, but that's fine. That's the point of the stream.
Yep.
Cuddle Puppy, Ken, off-topic question, but how do you have ads off? I have no idea. I've never tried to do ads. When I immediately got affiliate status, I turned off all ads. And I don't know if I got grandfathered in or something like that. I honestly don't know, Cuddle Puppy. But that's awesome that you guys aren't getting ads. I'm not here for the money. I'm here for the fun of video gaming, drinking alcohol, and talking science. So I'm glad it works out. Huggy Beer got an ad before the stream. I don't know. Do you have ad block up or something like that? I don't know. I truly also did not get ads. I didn't notice, but yeah.
Oh, I didn't realize it's kind of easy. Am I down?
Cuddle Puppy has to run 3 minutes of ads per hour. Wow. Yeah, I have no idea how that works. We made like $2 in ad revenue since the start of this stream after 84 streams of this. So I don't want ads. I don't care. I don't need to make money. You don't have to kill those. You can just keep going.
See. Gotcha.
That's crazy. Some people are getting ads and some aren't. I apologize to those that got ads. It's not intentional. I'm not making bank off this. I'm not quitting my day job. So I apologize. You have to sit through those ads. I'm curious what ads they run. Presumably they target the interest of the audience. So what audience do we recruit? And what?
Do you use the algorithm or does a human decide?
I'm assuming it's an algorithm of some
I see.
kind, but
Gotcha.
how many GPRs can we get from the ad revenue?
You can translate.
How much? What's the cost of a GPU hour?
Like 50 cents per GPU.
So we can get 4 GPU hours off of all the ad revenue I've ever gotten. Actually, I'll look it up right now for you guys. You guys want to know the ad revenue we've gotten from this stream since the start? I can look up these metrics, which is really cool that like Twitch has these analytics. All right, so we started streaming in 2020. We'll say January 2020. January 1st, 2020 through July 3rd, 2024. Let's do that. Update. Can I look up ad? Oh, it has subscriptions as part of it. Can I look up just ad revenue? Ad breaks, I have 0 seconds total. It doesn't let me do just ad revenue for some reason. Maybe it's somewhere else on here. I can't find it. I apologize, Detour. I'm not going to look it up right now, but my stream runs ads to help bully scientists. The way I see it, ads pay for the liquor shots. Absolutely. Yeah, any subscription or bits or ads or anything we get for the stream, we use it to buy alcohol. So I probably spend, what, 2 streams? I'd probably spend, what, $20 to $30 on alcohol per month on this?
It's like twice per month, I guess.
Yeah, so that's not too bad, but... All right, so you got to shoot the heart. You can blow up these guys if you want.
Oh, I see. So you can shoot above?
Yep. So you shooting the heart is what beats this boss, but you can shoot up the things.
Gotcha.
I de-affiliated because I refuse to subject my peeps to discussion interruptions. That's intriguing. Do I write off booze as a business expense? I probably should. And the streaming setup. Yeah, that's exactly it. Just run at the heart. I love the sound effect when you shoot the heart here.
Oh, yeah.
Man. Yeah, I'll have to look up the ad revenue. I swear it's something like $3 over the entire 3 years we've been streaming. It's something ridiculously small. Stream summary. Achievements. I don't know where I'd find that number. Yeah, I'll keep looking. I apologize, but $3 sounds about right. I mean, unless you have like thousands of viewers, it's just not cost effective to do ads.
Yeah, GG Contra.
Hey, there it is.
Yeah.
Congratulations.
I'm not sure like what is the last time I finished
I
this.
mean, Infinite Lives. You got the win though.
Yeah, definitely.
All right. Are you ready to jump into the world of NARC?
I think that's a tradition.
Yep. Every single guest at the end of the night plays
Gotcha.
NARC.
Gotcha.
Do you want to see the timer or don't see the timer?
Either way, like.
All right. We'll get the live split timer up.
Yep. What is the range of record? Like minimum?
So I think our fastest time is 16 minutes and 43 seconds or something like that, and the slowest time is like 38 minutes.
I see. I see.
And there's some point. Dude, I don't know why there's 2 timers there.
I can hopefully break one of the records.
They're the biggest or the smallest.
Yeah, it's a record anyway.
I respect your optimism. So we're going for the longest or shortest time tonight. Yeah, that's the way to play this game. I really like that. All right. So let me get this stream timer up. All right, we got that. Yep. We're going to put NARC on the screen. Don't press start yet.
Gotcha.
Ladies and gentlemen, anyone not familiar with the stream, every night we close. I force my guests to play NARC, which is a bargain bin game for the NES. It's You're Going to Win the War on Drugs, written and directed by Nancy Reagan. Just kidding. It's a stupid war on drugs, and it's manifest as video game form. Thankfully, I have the cartridge for the original Nintendo Entertainment System, so we can read the story so you can learn the background of this game before you play it. Are you ready? You are Max Force. Your mission: bust Mr. Big and destroy his dreaded criminal empire. Seize all contraband, stolen money, illegal weapons, use rocket bombs, high-powered machine guns, apprehend all suspects, protect the innocent, punish the guilty, and stop at nothing. That's it. That's your goal.
Gotcha.
And so NARC, the tagline is, no one had the guts until now. Also a comment on the cartridge. NARC is a game that depicts the war on drugs and supports our belief that winners don't use drugs. So, are you ready for this, Ben?
Yeah, I'm here to break the first record. If not, I'm gonna head to the second record.
Oh, man. All right. No player escapes this game unpunished. Ergo, we are all guilty. Absolutely. Wait till Mr. Big comes. Ben, are you ready?
Yeah.
Press start.
Gotcha.
And as soon as you hit the ground and gain control, your goal is to walk right as quickly as you can, find doors, and beat the game. And I'll walk you through. There's a few things where card drops happen and things, but for the most part, there you go. So tapping B jumps, holding B squats, tapping A is rockets, holding A is bullets.
Gotcha.
All right. Huggy Beer, you're just in time. Yep, keep going right. Ooh, do you keep your emotes if you de-affiliate? I don't think so. I think you have to have affiliate status to get emotes. Is that not true? All right. Write-off booze is a business expense. All right, if you guys want to distract Ben, he's really focused on beating the record, either long or short, so you can ask questions and really mess with him.
Yeah, I will beat at least one of the record anyway.
So we got distracted talking about airplanes and international flights out of Tallahassee, which may or may not exist. But the original question was, yeah, there you go. Well, that was quick. Nice.
Really?
Yeah, no, you flew through that part. You're high pressure. But like when you sit down next to someone on the airplane and they're like, "What do you do?" What's your answer on that question?
Like, are you asking like whether I asked any question?
No. If somebody asks you, "What do you do?" So your answer is, "I'm a professor. I do research." Like, what? How do you answer that question?
Yeah, I can almost predict the second sentence people gonna ask because they usually ask what you do. I will say like I'm a chemistry professor.
Yeah.
They're gonna ask what do you teach.
Yeah.
Yeah. So I think that happens almost all the time.
Yeah. And you say Gen Chem?
Yeah. In the very beginning, I'm trying to explain that the course I teach gonna change depends on which depends on the semester. Sometimes I teach Gen Chem and sometimes I teach P Chem, for instance. And also I typically gonna doubt if they really care about the difference.
Yeah.
So I will start to explain that most of the time I do research.
So you want to shoot these guys wearing black with bullets at a reasonably close range.
Oh, I see.
And one of them is going to drop a blue card. So hold the A button.
Oh, I see. Like this?
Yep. So yeah, hold both buttons to shoot the dogs. That'll turn them into puppies.
Gosh.
That's pretty fun. Misadventures. I hope Ben has been sandbagging this entire time. The idea being you're going to play NARC and dominate it. So shoot these guys with bullets, not rockets. Just hold A.
Hold A.
Yep.
Gotcha.
Hold A at close range. So that's tapping A.
Oh, I see.
Hold A. One of them's going to drop a blue card. So shoot that.
Oh, I see.
Yep. So you're going to keep doing that over and over again. So get relatively close to them.
Gotcha.
Somebody's going to drop. There it is. Go. Blue card right there. All right. Awesome. All right.
How do I use the blue card?
Through the slot.
Oh,
That.
I see.
Go through the door.
Gotcha.
Perfect.
I see.
All right. Huggy Beer's dropping some standard internet units. So he's redeemed both request a factoid and take a drink. So cheers, Ben.
Oh, cheers.
Cheers, Huggy Beer. Hopefully you have a drink in hand.
Yeah.
Ben is playing one-handed right now because he's drinking. Keep walking right. You're on a timeline. It's funny because the last guest was having a tough time with the questions and was focused on gameplay. Yeah, Eugene was taking it seriously, and he did complete the speed run for Aladdin in 38 minutes and something, so he's 217th on the leaderboard. So yeah, he wasn't messing around. My favorite part is I posted a YouTube video of his actual stream.
Oh yeah, I saw that.
It's got like 30 views or something. I posted the YouTube video of his speed run, and it's over 600 views.
Oh really?
Yeah.
Wow.
So some people are watching an Aladdin speed run, so press jump.
What is jump?
Tap B.
Tap B.
Okay, stay on the bottom and press right.
Gotcha. Oh.
Yeah, so I don't know. I think the keyword is speedrun in the title and more people watch it. But my favorite part is when the speedrun moderator has to watch that video, they're going to hear about like the feasibility of quantum computing, the likelihood of true random number generation, the logistics behind computational analysis of systems. It's amazing. Oh yeah, a bunch of people have the day off tomorrow. I think FSU is technically closed tomorrow.
Oh yeah.
Which is kind of fun.
I think also Friday.
So yeah. Well, the other thing about the stream with Eugene is we were doing shots. So tap the jump button. Tap it a little gentler. You can get next to it.
Oh.
Press close. There you go. Just tap it again. All right. Walk across. Physics.
Oh. Interesting.
But yeah, we had shots of this terrible strawberry tequila, and it was absolutely disgusting. But yeah, it was a fun gaming experience. So cheers, Huggy Beer. Thank you for having a drink in hand, joining us on a Wednesday night, talking science, playing video games, beating some NARC. We actually beat Double Dragon 2, Contra, and now you're going to beat NARC tonight. So keep going, jump over the top. Gohaku has redeemed take a drink, so Ben, cheers again.
Yeah, cheers.
Force you while gameplay. They're messing with your speed run. So keep going, press right, go to the bottom, you can keep walking.
Oh, go to the bottom?
Mm-hmm.
Gotcha.
Oh, man. Yeah, I don't use enough emotes. I really need to use them more. We don't...
Yeah, especially this is not for free.
Exactly. If I save some of you guys some ad revenue, I might as well entertain with some emotes. Oh, man. But Huggy Bear also redeemed request a factoid. So, do you have a factoid knowledge bomb you want to drop on the audience?
Yes. So I'm gonna pick one of them. Like, oh yeah, that's a cool thing. Like, we just did some literature review on that. It's a fun fact.
Yeah.
Yeah. So there are many compounds existing on nature cannot be synthesized in a lab.
That's crazy to me.
Yeah, so there are very simple compounds. For instance, like recently there's actually a very interesting paper. It's a geology problem actually. There are very typical things like calcium magnesium carbonate. Yeah, synthesizing that in a lab gonna take like 100 million years.
All right, so you're gonna jump in this car and stay on the bottom.
Yep.
Tap B, light, gentle. There you
Gotcha.
go. Stay on the bottom. Go up to the top.
Oh, I see.
Keep going, and you'll jump into a wall. Keep going. Keep
I
going
see.
right. You couldn't have known to go down, but
Gotcha. Oh, this is how people break the record.
exactly.
Now I realize.
Go Haku. Why is there no drink redeem cooldown? Because we just drink a lot. If you were here for a last stream with Eugene, we had so many shots of that shitty strawberry tequila. Detox for who? Ken or his guests? For me, because I do this every 2 weeks. Guests only have to do this once every like 2 years. So
It's every 2 weeks during summer.
yep.
Yes.
Every 2 weeks nonstop for the last roughly 3 years.
Gotcha.
Sometimes we do a 3 year or a 3 month or 3 week break. Oof, 3 drinks in, that'll do it to you. Yeah, we sometimes do a 3 week break, but generally, so go to the bottom. Oh no.
Oh, I
Okay.
see.
Keep going. Walk. That'll cost you some time, but that's fine.
Yep.
Cuddle Puppy, I've got almost 60,000 points saved up. I can personally fund an upgrade to the local detox unit. 60,000. I need to come up with more. I haven't updated the spending of points or the emotes or anything in a while.
Oh, the bridge is actually there's no enemy actually, so it just
Yeah. Keep walking.
Oh, I see.
But yeah, if you guys have questions for Ben, distract him while he's doing his gameplay. He's trying to do this, we'll say 20 minutes is your goal. If you get that, it's amazing.
Yeah. My goal is either 20 minutes or 38 minutes.
That's fair. All right. Heart Lukewarm wants to know, what's the difference between PChem and biophysical chem?
That's first of all, I have little to do with biophysical chem. Yeah, but I guess, did you teach biophysical chem actually?
No, I've taken biophysical chem. I took that as an undergrad.
Oh, I see.
Jump. Tap B.
Yeah, but I guess like maybe biophysical chem is more like a...
Through that door right there.
Gotcha.
A little bit more right.
Maybe like... Oh,
That's
gotcha.
weird. So biophysical versus physical chem.
Yeah, I think sounds like physical chem is more fundamental, and then biophysical chem sounds to me, I'm just guessing that. So it's more like applying the PChem theory into like a biological science, I guess. I haven't even taken biological chem actually.
Oh, you've never had biochem class?
No, not really.
I've often said, I've said this on stream, I want to be forced to teach biochemistry so I can learn it.
Oh, I see. Yeah, that's definitely a good strategy.
Yeah.
I was told like you really learn something when you teach it.
Yeah, exactly.
Yeah,
if I was forced to teach it, I would really learn the nomenclature. I'd learn the foundations. And
Exactly. Yeah.
figure out where I can contribute.
Yeah, maybe I should teach that. I really want to learn organic chemistry. Maybe I should.
Yeah.
I should teach that one
After
day,
tenure. Don't worry about it till then.
Yeah, definitely.
But yeah, if I had to say the difference between PChem and biophysical chem,
Yeah.
I would say there's a Venn diagram where those two things overlap, right? That's why it's called biophysical chem.
I see.
But the differentiation, physical chem would encompass everything from single atom measurements to like, physical analysis. This could be like quantum mechanical analysis versus thermodynamics of any given system. Biophysical chem is using, so go right.
Yep.
Biophysical chem is just applying those tools to bio-related problems.
Yeah.
So most of it, I think, is going to be thermodynamics related. Oh, go back in there. Go right. You're going to see a white card on the ground that says safe. You're going to pick up that card.
Yeah.
But yeah, anytime you apply physical chemistry to a biological-based problem or life-based problem, it's biophysical chem. So go back in there, grab that white card thing on the ground. So go right.
Yeah.
I'll point to it when you get there.
Gotcha.
So keep going, keep going, keep going. It'll be like right here.
Here?
Grab that thing.
Oh, I see.
And then go through the door. Oh, grab it. Press up. There you go. No. You gotta go through the door again.
I see.
This is gonna cost him. We're looking at 38 minutes, ladies and gentlemen.
Yeah, now it made me at 38 minutes.
Oh, man. All right, a question. Gohaku, what does the tech stack look like for computational chemistry? What is tech stack? I don't know that nomenclature. So go right. You're going to go through the door. Don't press up once you go through the door.
Okay.
So go in the door.
Yep.
But don't keep pressing up.
Okay.
So go through it. Go. Door.
I just go to this.
Yep, go through the door, but don't press up after you're through the door.
Oh, okay.
So just a little bit.
Okay, so...
Technology stack. What does the technology stack look like for computational chemistry? Go left.
Oh, I see.
Database, application, language.
Okay, so now I'm start to read the question.
Yeah.
What is the question?
No, so the question is, what does the technology stack look like for computational chemistry? So what database, application, programming languages do you use? Go right.
Yeah, I see.
So you talked about using Python. That's your go-to right now.
Yeah.
So press that right there.
Press.
Yep. Go right. There you go. Go through the door.
Gotcha. Oh, database? Yeah, so... Yeah, so basically, for computational chemistry database, there is no limitation.
Go right. Find a door.
Yeah, there's no limitation on which kind of database you use, but we use many lightweight databases simply because it's easier to use. We use MongoDB, for instance, a lot. Maybe like this?
Yep. Go left.
All right.
So don't hold the shoot button the whole time. Let go of the shoot button. When he gets close, then you want to shoot him.
I see.
So hold the shoot button when he gets close, but not the rocket. So you're going to have to shoot that Rambo-looking guy with bullets. So shoot the white guy, and then he'll come back, shoot him with bullets, and they're going to drop, he'll drop a green card. So you want to hold the A button to do the bullets.
Oh, I see.
Hold it, hold it, hold it. There you go, green card. All right. Green card and slot to the left. Watch out for the exploding marijuana.
I see, I see.
Kinky Pinky is the name of the clown. Holy crap. That isn't a Robert. You know the name of these characters. That is amazing. I don't know if they name it in the thing, but yeah, each one of these characters has a name. If you guys are interested, I have a speedrun tutorial that names every character and tells you what to do in this game on a speedrun. So you're going to go right, you're going to find a door here.
I see. How many times you play this? Like,
so fun factoid. Cuddle Puppy, you want to tell him or should I tell him? But what to do with this game on speed is to beat it faster, obviously. Speed is a performance-enhancing drug, so yeah, all my guests should do speed. Huggy Beer, maybe this is why we lost the war on drugs. People kept distracting the DEA with chemistry questions. All right, so fun factoid for you, Ben. I am the former world record speedrunner in this game.
oh, really?
Yep,
Wow.
I'm in second place right now on the speedrunner board because it was probably Cuddle Puppy that challenged me to this, but they challenged me to speedrun this as fast as I can, and I became the world record holder by 20 seconds, actually. I dropped the record from 9 minutes and 28 seconds to 9 minutes and 7 seconds.
Oh.
And then I got beat by someone that followed my rules to beat this game, so yes.
I see. Do you know that that person who break your rules?
I was in communication with them, so I told them they were the former moderator for the speedrun leaderboard. So yeah,
I see.
I know who it's Super Pitfro is the current record holder.
Gosh,
They
wow,
beat me by 3 seconds. So yeah, there you go through that. And so I've spent more time playing this than anyone should.
that's impressive.
It is on my resume.
Yeah,
And I'm submitting my full professor package this cycle, so
I see.
NARC speedrun is on there. But yeah, last minute questions. Ben has about, I don't know, 10 minutes left in this game. If you guys want to know anything about computational chemistry, high throughput analysis, data mining. Let's talk about data mining. We haven't done that. What does data mining mean in your world?
Oh yeah, so data mining in like computational chemistry is pretty much looking for like hidden chemistry rules. Yeah, so assuming that you have, for instance, thermodynamic data of like 10,000 materials. So you want to learn something. For instance, like can we learn Pauling's rules from like 10,000 of computational data? Yeah, so I think that's what we're trying to do. Like for instance, like in the very beginning, we talk about which element can do something special to us. Like I think that's one of the things.
Press start.
Yep.
There you go.
Yep.
So hold both buttons if you want to get rid of the dogs.
Oh, I see. Gotcha. Oh, that's cool.
Oh man, we're running out of time. We should do one more prediction because you guys got standard internet units that you want to gamble on.
I see.
Factoids and questions and whatnot.
Gotcha.
Maybe that's the guy you need to do 2-player speedrun with, the current champ. We are arch nemesis. We're not going to do that. All right, we're going to put a prediction up there now. If you guys have questions, throw them in the bin, or throw them in for Ben. He'll be happy to answer them. So Ben, what you're going to need to do is stand somewhere in the middle here. Kill all the guys on screen. When that wheelchair guy comes on, you're going to want to shoot him with a rocket. So that's going to be tapping the A button.
Oh.
Yep, there you go. So you don't have to jump. Just tap that A. There you go.
Oh, I see.
You kill the dogs, hold both buttons down. Then when you see the wheelchair guy, you're going to hit him with a rocket.
Gosh.
All right, so I'm going to put a prediction up there right now. This is a question about Ben, and this is kind of an arbitrary one. There's no way you can possibly know the answer to this. The question is, what is the maximum distance Ben has drove in Florida in one day? Is it 500 miles or 800 miles? And I look forward to the backstory on this one, but to give you guys context, between Tallahassee and Tampa, if I drive to Tampa and back, that's less than 500 miles.
Yeah, I actually use Tampa as a reference.
So the question is, what was the distance driven by him in one day? Is it 800 miles or 500 miles? And I love that you came up with this question, because it is, yeah, use any cheat you guys want. You are not finding this answer on the internet, as far as I know.
Yep.
Florida is phallic enough that driving through it is at least memeable? Yes. All right, so, yep, there you go. So rockets.
Yeah.
So press that button a little lighter. There you go. There you go. So that's one. You're going to have to do that twice more. So kill everything on screen. He'll come back and you'll have to do it again.
Gotcha.
All right, so what is the distance Ben has driven in one day in Florida? Is it 500 miles or 800 miles in one day? Oh, there you go. So he'll drop a gold card. Pick up that gold card.
Okay.
You go to the gold card.
Gotcha.
Next level. All right, you're flying.
Yep.
So unfortunately, you're not going to be the fastest time ever.
I have a second record.
Yeah. It'll take 38 minutes.
Yeah.
Oh, man. If this takes you another 20 minutes, we're in trouble. Top of the screen.
Oh, that's the last one, right?
Yep,
Yeah.
this is the last boss.
Gotcha.
So you're going to try to get a distance away from him.
Gotcha. Yeah, you told me that.
So you're going to turn around, jump, and then on the way down. Okay, stop now. Turn around, jump. Yep, rockets on the way down.
Yeah. I just need to hit the hat, right?
Yep, just hit the hat with a rocket.
Gotcha.
Dude takes 10 hours to beat Double Dragon, then he flies through NARC. Yeah, somebody said earlier he's just a sleeper. Like, he was just like conning us the entire time. He's grifting. It was like gambling. It was a warm-up, absolutely. We got some believers. Wow, Ben, so what's the answer? Everyone said 800 miles. What's your answer?
Yes, that's correct.
So what did you drive 800 miles in Florida in one day?
Yeah, it's like I step off my flight in Orlando, and then I drive to Miami, and then to the Key West, and then I drive back to Orlando because I have a presentation the second day.
Wait, sorry, you flew to Orlando,
Yeah.
drove to Miami?
Yeah, and then drive to Key West the same day,
Why?
Yeah, and then I have to drive back to Orlando. I arrive at my hotel at like 3 a.m. in the morning.
Wait, why did you do that drive?
I mean, it's just the fun fact is like this is when I get my driver license 3 months ago.
You're an amateur driver.
Yeah, I was probably too excited to get my driver license, I guess.
You're like, oh, there it is. Okay, rocket to the face.
Oh, I see. Gotcha.
No more jump rockets. Okay, now you're going to go down here and get away from him.
I see. Gotcha.
Ken, did you award points yet? I did, and the payout on this is 1.01 to 1 because everyone said 800 miles.
So,
So you want to be between these two black lines. So go down and around.
oh, I see.
Go that way.
Gotcha.
And you're going to turn around and you're going to shoot bullets, but you're going to move up and down.
I see. Is there any place I have to shoot? Like,
No, just kind of shoot the body. So turn around.
oh, I see.
So bullets, not rockets. So you're going to hold A.
Oh, I
Get
see.
away from him. Oh, there you go. You got one. Turn around. There's another one. There's another. Whoa. Okay, keep going. Turn around. Bullets to the spine. Move up and down a little bit. Done. Go right.
I'm down?
Crap. That was quick. Keep going.
Oh, I see.
Walk right. You'll find a door.
Gotcha.
All right. Wow, that was quicker than I expected.
Oh, yeah.
Points, yes. Go Haku, congratulations. Wow, very nice. Yeah, that deserves some GGs. So last level of the game, you're going to go right, go as fast as you can.
Oh, I see.
So this is civil forfeiture, the lever. You're going to steal a whole bunch of money from drug dealers.
Oh, I see.
Hit the key slot. 22 minutes and 14 seconds, Ben. Congratulations.
All right. Do I have a ranking on that?
Do you want to know where you sit on the leaderboard?
Yeah, I'm curious.
Let's find out.
The record is like 13 minutes, right? So like,
It's like 16.
oh, 16. Gotcha.
Not that's. I picked the wrong Excel file. All right, I know you guys want to know where Ben sits on the spectrum of all performers. All right, let's go here. So what was your time? 22 minutes and 14 seconds.
Yep.
All right, so where does that put?
Oh,
So you guys can see the Excel file, maybe a little bit.
Yep.
So fastest time, 16 minutes and 18 seconds by Adam Dewan. He got the big hat hit on the first try. It was pretty amazing. So where were you? 22 minutes and 14 seconds?
What does 2 mean? Like second time?
Yeah, the second time they were on the stream.
Gotcha.
So Rob Lazenby has done it twice.
Gotcha.
So second try, you do better.
I see.
So this puts you in the top, where are you?
Top 25, I guess.
Top 23. So that puts you right after Mike Roper. You
Wow,
are 24th
that's awesome.
place on the... Oh, you guys can't see it. It's right behind Ben's head.
Oh, yeah.
There you go. You guys want to see the scoreboard. All right. Wow, that's it. Congratulations. You can put your initials in right there because
I
you
see.
earned it.
So I just...
Question, do you have a middle name?
You know, like, did you watch Silicon Valley?
Uh-huh.
There is a guy who, Jimmy Ouyang.
Uh-huh.
Yeah, he used O. He has exactly the same last name as me, but he used O as middle name.
So it's Jimmy Ouyang.
Jimmy Ouyang. The last name is Yang. O is his middle character.
Yeah.
So it really depends on how you do this. Technically, I don't have middle name.
Yeah.
Yeah, but I realized he used O as his middle name, which is interesting.
That's awesome.
Yeah.
I did not recognize that. That's amazing.
Yeah. So should I use end?
Oh, need a distribution graph. Misadventures, that's fun. I'll have to put together a histogram. If you guys aren't following us on the on Discord, I regularly update with the progress or the success rates. Well, look at that Nightbot timing on the Discord. But if you follow us on Discord, I promise I will make a histogram at some point to see our guests perform on it. So
Do I have a Discord? I don't even know that.
you could join Discord on ours if you wanted.
Gotcha.
So yeah, you could be part of that. But press end.
To save it?
Yep.
Ah, gotcha.
It doesn't save. But right now, you are the best on our.
Oh yeah.
You are the top.
I'm the
scorer
best
from
tonight.
Discord.
All right. Nice.
Anyone, congratulations. We've beaten several games tonight. Double Dragon 2, Contra plus NARC. So you won the war on drugs. You won the war on whoever is in Contra.
Yeah, Double Dragon 2 seems to be really difficult for me.
Yeah, the jumps were hard.
Yeah,
Those were really hard.
Exactly,
That was a fun game, though, to play.
Yeah.
But yeah, if you guys have suggestions on people we should raid, let's find an hopefully educational education related, but we're happy to raid anyone that's of interest. Usually gets us a couple followers. Stick around so we can raid people with more than like one or two of us. But yeah, thank you all for joining us. It's been a pleasure. Ben, thank you for saying yes to this. I know it's an unusual request, but it is a fun time.
Yeah, definitely. I really like it.
Any parting words for the audience? Anything you want them to know? If you wanted the world to know one thing about computational chemistry and like machine learning, what would it be?
I mean, I just like it. Yeah, I really enjoy it. I mean, I typically people ask me like if you have a second choice, like which major you're gonna choose and which research you're gonna do. I think I will still choose the same thing.
That would be your answer? You'd still do it?
Yeah, I will still do it.
What do you think? Should people join you in the domain of computational chemistry?
Yeah, definitely, please. Yeah, I think definitely. So it's happening right now, and it's gonna be part of the future. Yeah, please join us. Yeah, definitely.
All right.
Yep.
Gigi, Misadventures?
Oh, yeah, that's for thank you.
Misadventures busting up the Chinese.
Yeah, thank you.
Yeah, we learned a lot about Chinese characters and periodic tables and whatnot.
Yeah, definitely,
so that's awesome.
Yeah.
that is perfect. We'll close the night on that. So
yeah, exactly.
Yeah, again, suggestions on who we should raid. But it's always a pleasure. I have a lot of fun. I drink a lot on Wednesday nights and play video games. Tonight I got to play, which was kind of fun. I usually don't, but we double team Double Dragon. But yeah, if you guys are interested, in 2 weeks from now on July 17th, our guest will be Dr. Michael Neal. He's actually a professor from the English department, the first English professor we will have on stream, and he's very interested in rhetoric and composition, multimedia composition, digital dilemmas and teaching. In particularly, he's interested in ChatGPT and its influence on writing and things like that in education. And so, yeah, he's very interesting in terms of that domain. So I'm excited to have Michael Neal on and have our first English department guest on. So thank you all for joining us. It's always a pleasure. I have a great time every single night. Ben, thank you for saying yes to this. I know it's an unusual ask. Yeah. And I make you guys do homework, but hopefully it paid off. Cuddle Puppy put some Chinese in there.
It said, by the way, I'm a dog.
He is Cuddle Puppy. Google Translate for the win. Is that right? And Google Translate did good?
I'm not sure what he's trying to say. The Chinese word means like, by the way, I'm a dog.
Yeah, no, that's it.
Sounds okay. So yeah.
Congratulations. Thank you, Cuddle Puppy, closing the night with some Chinese. But thank you all for joining. We're going to raid somebody. I'm a dog.
Yeah, that's correct. Correct.
Way to go, Google Translate and whatever AI machine learning did that.
Yeah.
Thank you all for joining us. We'll see you in 2 weeks. We'll join you from Michael Neal, an English professor that does technology as well as related to English. So, it's always a pleasure. Until then, stick around. We're going to raid somebody education related.